Hi everyone, welcome to this tutorial on R. Let's see what is R programming and how it helps. So R is well known as a language of data science. Now, if you really look at the ranking from survey of data mining experts based on the softwares they have often used in their work, R is used more than Python when it comes to data science. Python is also used, however, R is predominantly more used for data science kind of activities. It's a open source programming language used for statistical computing. It is one of the most popular programming languages today. It was inspired by S+, and it is similar to S programming language. So when it comes to data science, what we can say is R is a popularly used programming language across the globe. It is free and open source, as I mentioned. It is optimized for vector operations, which we will learn about later. It has an amazing community, has in fact 9,000 plus contributed or community packages, allowing us to do almost anything or everything using R. Now, when we talk about features of R, as I said, it's open source programming language. So you can install R for free and you can straight away start working. You wouldn't have to really go for a licensed version or pay for the software. Non-coders can also understand and perform programming in R as it is easy to understand, and it has various data structures and operators. It can be integrated with other programming languages like C, C++, Java, and Python. It consists of various inbuilt packages, a lot of sample data sets which can be used, and that makes reporting the results of an analysis easier by using R. Now, before we start learning about variables, loops, how you work with R, and so on, it would be good to know how you can set up R and work on R. So for that, what you can do is you can just go to r-project.org, and once we get to the home page of R project for statistical computing using this link, we can click on download R here. Now that brings you to a page to download it. Now there are various links here. So it shows you the comprehensive R archive network, that is CRAN mirrors, and it is available at different URLs. However, I would choose the first one, which is Zero Cloud. You can just click on this one, and then based on your operating system, whether you are working on a Linux machine, on a MacBook, or Windows, you can install it. So you can just click on this one. As of now, I'm using a Windows machine, so I can click on download R for Windows, and that takes me to this link which says binaries for base distribution. Now this is what we can use to work with R straight away. However, there is one more package, that is RStudio. We will see how we can set up that. Now this one takes us to the best mirror possible for our location from where we can download R. So you can click on this base and then you can download by clicking on this link. I have already downloaded this. So once you click on this one, you can just save it. So I have it here already in my downloads, and that's more than enough. Then you can just double click and you can go through the instructions to set up R. That would also allow you to basically set up a desktop shortcut, which I have already done here on my machine. And if I go in here, I see R base. You can click on this one, and that brings you to the page which you can use to straight away start working with R. Now, yes, there is one more package called RStudio, which is set up on top of base R, which makes working with R easier. Now, here also you can start working. So it shows you R console, and you can click on file. And if you have some scripts or files already written in the format of R, you can use those. So I can click on open script, and that takes me to a page where I have some files which are already existing. I can just select this one and click on open, and that shows me some options here. So I have an editor which shows me, say, if I want to get a library to use built-in data sets, I could summarize the data, I could do a cleanup, and we'll see all of this. But I would suggest using RStudio rather than just using base R. However, installing base R would be required. And depending on your machine configuration, like mine is a 64-bit, I have chosen 64-bit while I was setting up base R. Now, when it comes to RStudio, it is basically a package which makes working with R easier. So to install RStudio, what you can do is you can go to the RStudio homepage, or you can just go to Google and say type RStudio download, and then it takes you to this page. You can click on this which says download RStudio. You can choose your version. You can go for the free version, that is RStudio desktop, and you can click on this download, and then you can download RStudio for Windows, which I have already done, and then you have to run through the steps. So just click on this one, and I already have RStudio here, right? Now I can just basically use that. So for example, if I go to downloads and if I look for RStudio, if I do a double click, I can say yes, and then it takes me to the RStudio setup. Just click on next, and here you can choose the location. If you would want to place it in a specific location, click on next, and then it says select the start menu folder. So let RStudio be chosen here, click on install, and then it will basically start installing this in a particular location. Now in my case, it is already existing, right? So we can even click on show details and see what it is doing, what packages or what executables it is extracting. Now once this is done, then you will be able to use RStudio. You can also add a shortcut to your taskbar and you can continue using it. So I've already done this. This might take a couple of seconds. Just wait for this to complete and you would have RStudio, which is an easier way of working with R. So a lot of developers across the globe would be using RStudio when they are working with R to work on their data science or programming requirements. Now let's just wait. It is almost done. And now I can click on finish. So that part is done. You can add it as a shortcut. So RStudio has consistent commands. It has unified interface. It makes easy to navigate and manage through R. And it is set up on top of your R base. Now, if I click and open on this, so that's my RStudio, which is coming up. Now, here you see console, which will show you the result where you can give your commands. So where we can get text output. Now, again, I can choose a file. So I can just say open file, and then I can go into a particular location where I have downloaded some data. And then basically I can choose, say for example, RStudio, and that brings me here. So now you have your script which has some commands, right? On the left bottom you have console where you can see the output. On the right side you also have environment. Now that is to use or provide variables, and then we can also have plots which we can see here. Now we can look at this as an example. So here I am loading the built-in data sets. So what I can just do is I can place my cursor here and I can just do a control enter, and that basically loads the built-in data sets, which we can see here that has been done. Now there is an inbuilt iris data set, and we can just use head option to look at the first 6 lines of iris data set. So just place your cursor and do a control enter, and that shows you a summary, basically the first 6 lines of this data set, what it contains. We will look into this data set later. This is a default data set which you can easily find when you're working with R. You can also have your cursor placed on summary and then just do a control enter. So that basically shows you summary statistics for iris data. You can do a plot, and that basically shows you the plot, which you can also maximize and look at it in full screen. You can just do a zoom if you are interested in looking into this, and we will discuss how or what kind of information we can infer from the plots. Now, when it comes to cleaning up, you can just do detach, and then we can say package data sets. And here we had loaded those data sets. So we are just doing a detach, and we can say unload equals true. So I'll just do a control enter. I can also clear off the plots by doing this for whatever plots we had, and we can either do a edit and then we can do a clear console from here, or the shortcut is control R and you can clear off the console. So that's a simple way of starting your working with R by installing R Studio. So let's continue learning about working with R. And basically the first thing which we should learn here is about variables in R. So variables, as in any programming language, is a way to store your data value, factor of list values, or a data set or object in R. It allows us to conveniently reference the variable name, basically saving us from rewriting the data value or object many times in our program. So when we talk about variables in R, they are mainly used to store data with named locations that your programs can manipulate. A variable can be a combination of letters, digits, period, and underscore. So you can have some valid variables as total, sum. You can also have dot notation. So there are different naming or style conventions in R, and we can use dot to separate names in description of a variable. We can also start a variable with dot. We can include numbers in a variable. And remember, R is case sensitive. So we have to, whenever we declare a variable, we need to remember what case was used, as in the name of the variable. And there can be other conventions also, such as using an underscore or even using a case in between the variables. So variables can only consist of letters, numbers, periods, underscores, your dot followed by a letter, not a number. And we can declare our variables. We can also look at the type of the variables and the class to which it belongs. So there are some invalid variables which we are seeing here, so that also needs to be remembered. So this is an example where you can use an assignment operator, which you see here between x and 10, to assign a value to a variable. You could also do that by doing a dot y and then assign a value. You could be doing that by using a z and then having a computation done between x and y, and finally you could do a print. So let's see some example here before we move further, and for that I can bring up my RStudio here. So as I said, we can basically have different kind of variables or naming conventions. For example, I could do something like model 1, and then I can basically assign this. So this is just a variable, and I could be assigning anything to it. I could be assigning different data types which are available here. For example, I could do something like this, and I could do a control enter. So that's my variable. I can always do a type of, and then basically I can check what is the type of my variable. So it tells it's a character. I can also do a class, and then I can basically say show me the class, and that shows me it belongs to the character class. We'll learn about data types later, but we are using an assignment operator now. If I say what is model 1, it shows me the value, but if I would do something like this, then it says object model not found. And why? Because it is case sensitive. The variable which we had created was all in lowercase, and the one which we tried to call was starting with an uppercase. So you could have variables created in such way. I could also do something like hello underscore string, and this could be my variable where we are using an underscore, and then we can just give in something here, and that becomes my variable, which you can always call and check what is the value of that. You could also be doing something like this. So you could be using different cases, and then I could say something like this, and that's also my variable. And then I can basically look at the value of this variable. Now, if we try to create a variable where we start the variable name with a number, what would happen? So if I say something like this, and then if I try to assign a value to it, for example, let's say 100. Now this one will throw an error message because you cannot have your variable starting with a number. But if I used period and then basically give something like this, and let's try doing this by giving it a number. So if you see here, since we gave a period, the rule is that it should be followed always by a letter and not a number. So I could just remove this and that works perfectly fine. So these are some naming conventions which when you practice you will learn about. So now I can assign a variable by just doing a dot pairs and then assign any value to it. But always remember, if you are using a period, if you are using a notation, then in that case that should always be followed by a letter. One more thing which is always practiced in a real-time environment is that we cannot have spaces when we are creating variables. So for example, if I say first num and then I try to assign this a value, it basically fails. But obviously I could have done this by doing a underscore, and that perfectly works fine. And you can basically then call the value for this one. Always remember, one more standard practice which is followed in real-time environment is you will try to have variable names with a little meaning to them. So for example, if I would create a variable and I would say, for example, let's say bird, that's my variable name. And then if I assign this a value tiger, it works fine, but then it really does not make sense. And that would basically create a lot of ambiguity in our coding. So it is always good to say, for example, animal, and then I would say, okay, so tiger is an animal, and that basically not only allows me to assign a value to the variable, but it is also a little bit more meaningful. Now, when we talk about variables, it is also good to know the different data types which are available in R. Now, like any other programming language, R also supports different data types. So you have your logical data types such as true and false. You have numeric values, which is say these numbers. You could also be creating an integer, which is 3L and 40L, 4L, and so on. You can have a complex number. You can have characters, which can be just letters or a set of letters or anything which is within the quotes, or you can even have raw data. So these are different data types. We can again see quick examples here on data types. Let me come out of this one. And as we saw already, when we created model 1, this was character. Now I can just say X and let's say 100, and obviously this is going to be not my integer. Okay, so let's see this. What is this one? This one by default is double. It is by default double. So if I would want an integer, then I would say, for example, something like this. And this one you can check by using type of, and you can see the value for this one. So this is an integer. So similarly, you can have character, you can have complex, you can have raw data, you can have numeric values. So all these are different data types. You could also be saying, for example, I would want to check the Boolean. So I could check this and select this one. And now when I check the value for A, it is true. And we will learn about logical operators, where we can basically be using these values assigned to the variables to compare, to compute between different variables. So this is a simple small example of using variables. So we have seen here using variables and also using the assignment operator, and then assigning values to the variables and different naming conventions. We can also be using different data types which R supports, and work with the variables. Now, once we have learned about variables or data types, let's also just first learn about your operators and how they can be used in your R programming language. Now, we might be intending to do some calculations on numeric values, find out differences between values, or say, for example, compare values. So in that, we can be using different kind of operators. So we have various operators. We have arithmetic operators, we have rational operators, we also have logical operators. So before we straight away look into logical operators, let's also understand about the basics, such as your arithmetic operators, which supports, for example, let me pull up a notepad file here. And when we talk about arithmetic operators here, we are talking about your addition, you have subtraction, you have multiplication, you have division, and you have remainder or modulus, and you have exponent. And what makes it also important is that when you're using arithmetic operators, you also need to know about the order of operations. So when you say order of operations, always the priority is to parenthesis. So that takes the priority. You have then exponent or your computation if that would involve exponent. So let's say exponent here, which is then followed by your multiplication and division. And that one also follows an order of left to right, whichever comes first when we talk about multiplication and division. And similarly, when we talk about addition and subtraction, it is left to right, whichever comes first. So these are some of the arithmetic operators. Now we can see some examples here quickly, although these are some simple examples. So for example, I can say 100 plus 100, and that gives me the value, right? You can always do 100 minus 50. You can do 100 multiplication. You could do 100 division 2, or you could also use modulus 2, which basically gives you an error here. So I will, oh, just give me a minute. So let's give here one more percentage sign. And that basically says what would be the remainder. So if we would want to look at the ordering when we are using this arithmetic operators, we can see an example. So for example, if I say 34 plus 46 divided by 2 gives me 57. However, if I use 34 plus 46 in parentheses, which gets the priority, and then I divide, my result is different. So understanding what arithmetic operators you can use, and also the ordering in which that leads to the computation, is very important. So we can use all of these arithmetic operators, and to control the ordering, we can be using parentheses, or we can have our computations ordered with what kind of operation we would want, whether that would be multiplication or division, addition, or subtraction. Now at any point of time, I can always do a control L, and that allows me to clear my console. Let's continue our learning and let's learn about operators. So when we speak about arithmetic operators, we see that allows us to do computations, but we have also rational and logical operators which help us in doing our computations or comparing values or sometimes finding difference between different values, whether those are group of values or whether those are individual values. So with your rational and logical operators, you can compare data values. So if we would want to see if the values match or not match, or if the values are above or below, equal to something, and so on. So when we talk about your rational operators, we basically have, in case of rational or logical operators, so we obviously have greater than, you have less than, you have greater than or equal, you have less than or equal, you have equal to, and you have not equal. These are some of your rational operators, we can say. And when you talk about your logical operators, then you have and, you have or, and you have not. So and is when it compares two values. So it returns true if both the conditions are true, else it will return a false. So for example, if I have 10 greater than 20 and 10 is less than 20, now that's not possible. And we are comparing the result of both of these. So we are checking if both the conditions are true, and that's not really true here. So we see the value as false. Now, if I would have replaced this and with or, it would check even if one of the conditions is true, it would basically show me a result as true. You can also use a not operator, which takes each element of the vector and gives the opposite value. So we can be using any one of these operators and then basically do our computations. So let's see some examples about these logical operators. Now either you could just be assigning values to your variables and check, or you could also be picking up a data set from your machine and then try to use these logical operators. So for example, if I say X has been assigned 100, Y has been assigned 200, and if I try to say X equals Y, so that already checks the value and compares and tells me that's not true, it is false. And if I would have used a not operator, for example, if I would have said something like this one, so it tells me true. So I can just check simple conditions like this. I can say, is my Y greater than X? And that tells me yes, it is true. If I say Y is greater than or equal to X, well, it would still say true, because when you are saying greater than or equal to X, so when you're saying this one, it works fine, right? Now we can also be picking up some data set, and for that what I can do is I can pick up one of the data set from my machine. So I can go in here and I have some data sets. Let's look into that. And I would be interested in taking this auction data set and loading the values here. So I'll get this path and I will come here. I can use auction as my variable name. You could have given a dot separated name. For example, I could have said auction dot data if this is what you want to do, and then you can assign variable a value. So here I'll say read.csv, and I intend to pick up a file, so I give this path. And when we are working on Windows machine, we need to give a double slash So I'll say auction.csv. Now I could give other things like header being true, what is the separator. If you would want to fill values to take care of missing values, we can look at all of those. So here I'll just add a backslash. I will add a backslash, and I will basically just do a control enter. Now I can look at the values of this by just doing a auction.data, and I can see what values it has. So it has a lot of data here. It has a lot of your data here. You could have used some other functions which we can see later, where I can choose head and I can see the first top 5 values. So we can basically assign data to the variable and continue working on this. Now we can keep it simple. So let me repeat this step, and here I will say auction as my variable name, and I'll assign this. So I can basically do also a view on auction. So auction, and then basically that shows me a tabular format of the data, which allows me to look into the data and basically understand it, and then I can, you know, use this to work on variables. So what I can do here is I can say X, and let's say assign some value to this, for which I would want to work on my data set, which is auction. Now what do I want to do here? So let's use auction, and then I can use a dollar symbol, and I can choose which column I'm interested in. So for example, let's choose bidder, and I can just give a value to this one, and let's pick up a name. So let's say tweak, and that's the name. And I can be assigning all the values to this, or I could say I would want to use another condition. So I'll say auction dollar, and then let's take this value of bid, and let's say it is equals to 100, and then I ended up with comma, and I can try doing this. Now here it gives me a problem, because what we did was we did not use the right operator. So we will say, for example, and. So I will say X is being assigned the value of auction bidder being tweak, and auction bid value being 100. So now once we do this, I can look at the value of X, and that shows me the value. So this is just a simple example of using a logical operator. Now I could have just said, instead of and, I could have used or, which is basically a pipe which you have to use, and that gives you or condition. And now hit on enter, and if I now look at the values of X, it will show me a lot of values, because we have given an or condition which basically matches one of the conditions. So in this way we can use logical operators and continue working and continue doing our computations. Let's learn about print formatting and how print can be used to view your data. When you talk about R, R uses print function to display the variables. So for example, if I have assigned number 10 to X, I can do a print X, and that will show me the value of X. What we see here with 1 in square brackets, that also has a meaning, which basically means it is a vector, and we'll learn about vectors later. So R uses the paste and paste zero functions to format strings and variables together for printing in few different ways. For example, if I would do this, which I say is print paste, and then pass in two strings here or two words here, such as hello and world, that would be printed as follows. Now I could also do a print paste and then use a separator. So my print would look something like this. If I use paste 0, then that avoids any space between these two words, or for example, these three words. So let's see some basic examples here when we talk about print. So for example, if I bring up my RStudio, here is an example. So X, as we say, now this is your assignment operator, which we already discussed. Now I can be assigning a value to this. So I can just place my cursor here and I can just hit on Control Enter. So value has been assigned. Now let's look at the value of X. Now I could also be doing a print X explicitly by using print function. For example, if I do similarly for message as hello, and then I can print the message by using print. Now, if for example, I do something like this is not going to print anything until I call the variable or I use a print function. So for example, if I do a Y, we see auto printing shows us the value, or I could do explicitly by using the print function by explicit printing. Now whenever we look at this number 1, as I mentioned, it means Y is a vector and 5 is its first element. Now you can also use operator to create integer sequences, and we'll learn about sequences or list later, but this is just a simple example. So I am creating an integer sequence of length 20. I can place my cursor here, which would start with 10 and end at 30. So let's look at this values for our sequence of integers. Now at any point of time, you can always use a class to look at the class of say X, and that shows me the classes of integers. Now looking further, when we talk about different data types, as we learned few minutes before, so R has basically 5 basic or atomic classes of objects. So you have character, numeric values, that is real numbers, you have integers, you have complex, and you have logical values. Let's spend some time in understanding some basic arithmetic operations and how you can do it using your R programming language. Now here I've opened up RStudio, and these are some basic examples such as performing arithmetic operations. Now for example, we can add two numbers, and I can just place my cursor here and press Control Enter. That shows me the addition. I can do a subtraction, I can do multiplication, division, also going for exponential power, or use modulo, which returns the remainder. Now, when we are performing operations, what we can also do is we can change the order of operations. And in this case, we are using parentheses. So I am putting in 500 into 2 in a parenthesis plus 80 divided by 2. So first it operates what is given in parenthesis, and that's why I get a result 1040. Similarly, I can change the order of operations. So here I can give 500 into and then something in the parenthesis, so that gets operated first, and hence you get result of 1500. Now we have already discussed about the assignment operator, and what we can do here is we can assign variables some value. So for example, I create a variable called selling, and then I would assign it a value. Similarly for cost, and then we can do some calculation. So we can say profit is selling minus cost. We can do that, and here I can look at the value of profit, which shows me 250. Now let's also spend some time in understanding data types in R. So we can have different types of data. So this one shows me an example of assigning a decimal value, which is part of a numeric class. So I can do this, and then if I would be interested in seeing the value of num, so I can just look at the value of num. If I would be interested in looking at the type of num, so I can do that here by just typing in type of, and then select this one and pass in your num, and it shows me the value is double. I can also look at what class it belongs to, and that shows me it is numeric. So in this way, you can not only assign values to a variable, but you can look at the class and type of it. Now here we can assign whole numbers, which are also known as integers. Now if I look at the type of this, it shows me double. So if I would want to explicitly assign an integer, I could have done, for example, let's say j, and I could have used the assignment operator, and I could have done this. And then if I look at the value of j, it shows me the value. But what we would be interested in looking at the class of j, so we can do this and it shows me it is an integer. So explicitly, either I can assign this by using a capital L, or I could use a function called as.integer. So we'll see that later. Now we can also assign Boolean values, or basically your logicals. So here we assign true and then we do a false, and we can look at the type of T, and that tells me it is a logical class. Now similarly, you might be interested in working on text or string values, and here we can do this by saying ch and then passing in a value. Look at the class of this, it tells me it is, the data type is character, and if you look at the type of it, it says me character. Similarly, R also supports complex data types, so we can do that too by just doing this and look at the class of it. It tells me it is complex, and you can also pull out the length of this by, now here we are doing a length on the character. So let's look at this one, and it shows me what is the length of this. Now, one of the useful functions which we usually use in R is print. Now I can simply do a print hey, and that prints whatever value is passed to print. I can assign a value to a variable and then print it. So that is also fine. You could have also, without using function, just typed y, and that also shows the value. However, sometimes using print as an explicit function can be useful. It makes your code more readable. Now here we would use an inbuilt data set, that is empty cars, and then if you would want to print the data set, that shows me the values, which shows me the car models and different other features such as mileage, cylinder, horsepower, and so on. Now one of the use case of print with a paste function can also be seen here. So I'm doing a print paste, and that basically prints whatever was passed in a concatenated way. I could also do a print paste with a separator if I would want to format my data in a particular way. So here I've used separator as comma. There is one more function, paste 0, which can be used. So I'm doing here paste 0, and that tells me just concatenate these values without any space. So paste 0 shows no space between these two elements which were passed. Now we can explicitly do some printing, and for that I'm using a sprintf option. I am going to pass in %s, which is for string, and %f for float, and we can print the values of this. So these are some basic operations or usage of your functions to basically do some computations or look at your results. So when you talk about basic type of any R object, it is a vector. And when we talk about vectors, empty vectors can be created with vector function. A vector can contain objects of same type or a class. Now when we talk about list is a vector which contains objects of different classes. So these are some basic examples. So apart from your print formatting, we can be looking at what we call as R objects, such as vectors or lists and so on. So when we talk about vectors, it is a sequence of data elements of same basic type. We use the function to declare a vector. So we can always do a C function to declare a vector. For example, here we are creating a variable v1 and we are assigning it a vector by using C and then giving some basic types, so numbers 1 to 5, or for example words. You can always do a print, or you can also use a class to find out what is the class of the elements or the values which have been passed to the particular object. So we can look at some examples like this. For example, we can see here, so list is a vector which contains objects of different classes. So you can have numeric objects, so that is your numbers such as 1, 2, etc., which are your numeric values. For example, here what we are doing is we are assigning a value 1 to A, and that can then be used. I can either do a print or I can just use auto printing. I can also do here a value for AI, or I could be doing something like this, which shows me 0, which can be for missing value. So if I would want to use auto printing, I can just call A and it shows me the value what has been assigned to it. You can always use a type of to look at the value of A, which is double by default. And if I look at type of AI, that is basically an integer because we used L here. So in this way, we can continue working with, say, different classes of objects. So for example, let's create a vector here. So I can say v1 and then basically assign it by using a C function and then pass in the values to this one, and that basically gives me a variable, and you can look at what are the values assigned to it. Now if I look at the class of v1, that shows me it is numeric. If you use type of, and then you would want to see the values of v1, that shows me the values are double. Now as we were seeing here, we can be looking at the class. So for example, if I create one more variable and then assign values to it using C, so passing in some words here. For example, let's go and say hello world, and then I can basically do this and look at the values of this one. I could also explicitly print, as we discussed earlier, by doing a print v2. We could also be having a paste function if we would want to use that. So for example, if I would do a paste function, I could be using, and this is missing a bracket, so let's complete this, and that shows me the value. I could have also used, for example, paste 0 function, and that also works fine. So it depends on what we are looking at here. So if I look at class of v1 which we had, it is numeric, and v2 is basically having elements which are of the class character. So this is just a simple example of having your print functions, having vectors created, printing out the values of those, printing out class and type of these. To continue our learning on vectors, as I mentioned earlier, we can use the C function, which can be used to create vectors of objects by concatenating things together. So for example, if we look at this one which says X, and then I use C function and I say 0.5 and 0.6, so we can have a vector of numeric types. So let's do this, and then we can look at the value of X. So it shows me my vector which has 0.5 and 0.06. I can also have my vector of logical values, and now let's look at the value of X. So it has true and false, or we could have done it in this way where we can then look at the values. So we can use the short form by using capital T and F. I can create a vector with character types and then look at the values of those. I can also be creating a sequence of integers as we saw in previous example, and then look at the values which start at 9 and end at 29. Now you can also create with complex types and look at the values. So these are some simple examples of creating vectors. Now we can also use vector function to initialize vectors. So for example, if I would do this, where I'm saying my vector will be of type numeric, length is 10, and then look at the values. So it just shows me a vector which has all zeros and the length is 10. Now you can create a vector of numbers by doing this, as we saw in previous example, and use explicit printing to look at the values, or might be a letters, and then use a print statement to print function to basically look at the values of the vector. Now we can also try concatenating the above two, so that creates a mixed vector which has two different kind of types here. So I can do a mixed vector by using the C function and then passing in my numbers, which has numeric types, and letters, which has character types. And then we can basically do a printing of this, which shows me the value. But here what we see is coercion. That is basically casting, if you would know as the word in different programming languages. So it basically coerces the numbers to character, as characters cannot be coerced into numbers. And then you can print the values of this mixed vector where everything is of character types. So for example, at this point of time, if I would have done something like class of mixed vector, and if I would want to look into the values of this one, it shows me everything is of character types here. Now data type of different vectors can be returned by the function class, as we saw just now. So it is common to use the class function to integrate an object asking what is the class. Now we can create one-dimensional objects such as an integer vector, which we have done earlier, and then look at the class of it, which tells me it is an integer. I can also create a numeric vector by giving in some values here. So when we do this, so I have given the vector function C and then giving in the value and look at the class, it shows me it would have numeric values. Now you can create a character vector and then basically look at the values of it. Now at any point of time in all of these, for example, if I would do num, I can see what are the values assigned to it. I can do letters, and I can see the values of this. So let me just create some space here. Now I can create a factor vector and then look at the values of it, or also you can see what is the value in this factor vector. So here we said as dot factor, so factor function is being used here, and we are creating a vector of letters, and then we look at the class. We also look at the values what are assigned to this or what are in this particular vector. So if you look into all of these vector examples, initially we were using an assignment operator where we were using the C function, and when we started creating vectors by say concatenating or vectors of particular types, we are using equals here, and that also is fine. Now looking further, when we look at concatenating two different kind of vectors, so for example here we have say numbers and letters, as we discussed earlier, it will do coercion, that is change one type into other. Now when we talk about one-dimensional objects, we can have integer vectors or say float, which we saw just now, ending at 10.5. So when we say C 1 is to 10, it basically starts with 1, but then there is also, you can say, a coercion happening here, and then you have the values ending at 10.5, that is float, and I can look at the class of it. And when we did a class of Did we do a class? Yeah. So let's come here and let's do a class of this one. It says me it is numeric. You can look at the values of it. Similarly, you can create a character vector which is 1 to 10 and then basically look at the class of it, or basically the value of this vector, or as we did the factor vector. Now for two dimensionals, we will explore that when we are learning about matrix. So as of now, let's forget that. Now when you talk about mixing objects, there are occasions when classes of R objects get mixed together. So that could be accidentally or that could be intentional. So if you look at this example here, we have Y, which has been given values which is 1.7 and A. And at this stage, if I would look at the value of Y, that's my vector. If you look at the class of Y, that shows me it is as character. Now when you look at some other examples, so let's pass in logical and numeric values. What would happen in this case? So we can again use class of Y, and that basically has numeric. And if you would want to look at the value of Y, that shows me 1 and 2 here. Let's go further. So let's look at the value of this one. So Y, and then basically see what is the value of Y. So it is A, true. And you can also look at the class of it. Now we are mixing objects of two different classes in a vector. Remember, when we talk about vector, we always talk about vector having elements of same type. But when we talk about lists, which we will learn later, that would have basically, or that can have your each element of different type. So for vectors, it is not allowed. So when different objects are mixed in a vector, coercion occurs so that every element in the vector is of the same class. Now, we have seen earlier the implicit coercion, where R tries to find a way to represent all the objects or elements, as I say, so all the objects in the vector in a reasonable fashion. So we can also be doing explicit coercion, so that is from one class to another by using a as dot and then using a relevant function. So if I have X here, now if I look at the class of X, it tells me it is an integer, but I can convert that to numeric by doing a as dot numeric or as dot logical or as dot character to basically do a coercion and change the class of the objects. Now, if R cannot figure out how to coerce an object, this will result in NAs being produced, which we can also relate to missing values or not applicable values. So for example, if we create X and look at the class of X, it tells me it is character. Let's try changing character to numeric, which will not work. And it says NAs are introduced. If you do it even in logical, that would not work, and it shows me NA values, or if you do a complex, it says values have been introduced. So at this point of time, if I look at the value of X, it tells me it was assigned ABC, and we try to convert that into a different class. Now, when we talk about vectors, it is also good to know about attributes in brief. So all your R objects have attributes, that is metadata for object. So when you talk about R object attributes, you could have names, you can have dimension names, you can have the dimensions, that is matrices and arrays. You can look at the classes such as integer, numeric, and so on. And you can also look at length, which is user defined attribute. So if I say X, we are assigning a value to X. Now at this point of time, if I see my value to X is 1, but then all objects need not necessarily have attributes. So in that case, whenever you try to use an attributes function, that would return null. So at this point of time, if I look at the attributes of X, it shows me null value. So these are some of the basics which help us in working with R and using your vector function, or looking at the coercion which is implicitly happening or explicitly can be done by us by using a as dot sum function. Now let's learn about lists and how we can work using R on list. When we talk about vector, which we saw in previous examples, vector is a one-dimensional array, right? And it can hold elements only of same type. So we would say vector is more of one-dimensional. But when you talk about list is a generic vector that can contain objects of different types. So when you talk about, say for example, matrices can also hold elements of same type, but in matrices it is a two-dimensional array. We will talk about matrices also, we will learn. So when you talk about lists, they can contain all kind of R objects. So you can have dates, you can have data frames, you can have vectors, and many more. So in list, there is no coercion which is required, that is changing of data type. There is no loss of functionality, and lists do not follow any predefined structure. Now we can create lists using this list function as it is shown here. So you can create a variable and then assign a list to it, where you can be using either passing in a vector, or what you can do is you can simply create a list by using this list function. So let's see some example here. Now for that, what we can do is I can bring up my R Studio, where we can see an example on list and how it works. So when you talk about list, what you can do here is, let me close this one and this one. Yeah. So what we can do is we can basically say, for example, test, and I can basically give something here. So for example, I can say music tracks, and then I can say how many hundred of them, and I can say, let's give 100 as number, and then we can say how many of them got 5 stars, and I can do this. So I can check this, and this shows me all the objects or elements of this list, right? Now when we do this, what we are doing is we are creating a vector, right? And vector basically can have coercion depending on what are the elements which are passed, because whenever you use the C and you create a vector, it will only accept elements of the same type. So for example, if I do a class on test, it shows me here all the objects are of type character, right? And you can also use type of to check for our test variable, and it is basically having all the objects as character. Now how would you create a list? So what we can do is we can use a list function. So for example, let's again do a test here, but this time I'm interested in creating a list, and list can have objects of different types. So let's say music tracks, and then I can just give 100, and I can say with rating 5. And now if I look at my test, it shows me all the elements of your particular list. Here we see each element or each object with a double bracket, and we can see each element. Now what we can also do is we can use is list function, and then we can pass in test here to check what is it, and it is a list, right? So here we have created a list, but if for example we take the previous example where we were creating a vector, and if I would do a is list, it would show me false, right? So we just created a simple list, and we can also arrange labels, or we can use a name function to basically give names. So what I can do here is, let me create a list first. So I can do that like this. And now what I can do is I can do a name, and I can use a name function to this test. And then basically what I can do is I can pass labels. So here I can just give in some names here. So for example, I can say, let's give it a name, product. So say we are talking about product of a company, and then we can say here I can give count, and here I can give rating, and this is basically to give in names. So let's just give, there's some error here, let me just check this. So let's use this name function here, and what I'll do is I will basically use names. And now let's do a test. So that shows me the names what we have assigned to our list objects. Now we can always access the elements of or objects from a list using indices or even using double square. So for example, I have test here, and basically I can give something like this, which gives me based on the indices the position where you are accessing the elements of the list. So we can do this. What I can also do is we can specify names when creating a particular list. So for example, what I can also do is I can say product dot category, and now I can just give list function. So I would want to assign names while creating a list. So I can say, for example, product, and this would be, say, music tracks. Then I can give, say, for example, count, and count would be 100, and then ratings, and I can say 5, and now we can basically access this list which we have created. So what we have done here, unlike earlier when we created a list and then basically used names function to assign a name to it or each object, here while creating a list itself we passed in the names. So we can also do that. Now if you would want to basically display the list or compactly display structure of a list, we can always use the string function, and here I can pass in the name. So let's choose this one, and this is in a more compact way listing down the elements of your list. So list can be containing other lists also, and we can also do that. So for example, I create one more list. For example, I can say similar product, and here I can give a list again, and what I would want to do is I would want to say product equals, and I can say film, and then I can basically give a count, and then I can give ratings, say 4. And here what I've done is I have just created one more list, but my intention is not just to create a list, but I would want to add this to our existing list. So what we can do here is we can take our previous list, that is product.category, like what we did earlier, and now I intend to say list, and here I would want to say, for example, let's copy this, or we can just, so this is what we were doing when we were creating a list using product, giving the names while creating a list. And what I also want to do is here I will just say similar and then pass in similar dot prod. So now if you look at our list, we have just added new elements. So this is one more way where we can create a list and we can basically add, or our list can have other lists. So when we talk about subsetting or extending list, so one of the main ways, as I said, to access a specific element or a subset, we use double brackets, and we can always do that. So for example, we take our prod dot category, and then I would want to access a particular element. So I can always do this by giving the index positions, and I can access the elements of my list. So this is one single way. Now here, if we use a single bracket instead of double bracket, then in that case, the output would be a list. So if I look at this one, then this would be a list. But if you use double brackets, then you're accessing a particular object. If we were creating a vector, we could just be using a subset by using the C function. Now, what we can also do is we can subset by names or even logicals. So what we can do here is we can take this product category, and if we have defined names, then in that case, what I can do is I can say I would be interested in music tracks, and this is the name we had given. So we can close this one, and we can try accessing the elements here. So what's the name we had given? So no, it's not music tracks, that's the value. The name is product. So we do this, and then we can access the elements. What we can also do is we can be subsetting based on logicals. So what we can do is we can basically just give something like this, and here we can pass in values. Something like this. And we missed a bracket. So that's also a way of pulling out the values. So you can be doing a subsetting using the names which you have assigned to objects within your list, or you can say names which you have assigned to the elements, or by using logicals. Now what we can also do is we can use the dollar function. Now if you see here, we are looking at the name, and that is preceded by dollar. So we can always pull out the values from our list by giving the list name and then give a dollar symbol and then choose the name. For example, if I choose product, I can list the values here. I can be looking at, say, dollar and then choose a count. And this is also one way of accessing your elements from the list using your dollar symbol. Now, to add elements to a list, as I said, you can add a vector of names, and that can be passed to your list. So these are different ways in which you can work with list, and then you can access the elements either using indices or using names, or even using dollar symbol and pointing the right names. So this is one simple example of working with your list. Now one more, and now I can just do a Control L and I can clear that off. So your list, always remember, is a generic vector that can contain objects of different types. Now when we talk about matrices, now matrix is a collection of data elements arranged in two-dimensional rectangular layout. So we can use matrix function to create a matrix as shown here. So matrix is two-dimensional. Now we already know that vector is one-dimensional array of data elements. or a sequence of data elements. But when we talk about matrix, it's a collection of data elements that is two-dimensional, arranged in fixed number of rows and columns. So here you see that we are creating a matrix, and we have specified the number of rows is 3, number of columns is 3, and we want it to be arranged by row, where we have given the value as true. So always remember, matrix is two-dimensional, and matrix can have only one atomic vector type, unlike your list. It's a natural extension of vector going from one dimension to two dimensions. So matrix actually needs a vector which contains values that you place in a matrix, and at least one matrix dimension. So we can choose to specify the number of rows or number of columns when we are creating matrix. So let's see a quick example of working with matrix. So for example, I could just say matrix, which will have values 1 to 6, and then I can basically give n row, and you can give a value to this one, and that's my matrix. Similarly, you could also be giving n columns. So I can just say n col, and I can choose this one and then pass in the value. So that's a matrix where R fills values column by column. Now if you intend to fill up matrix in a row wise fashion, so that your values 1, 2 and 3 are in first row, then we have to just modify this in a little bit different way. So we have to say matrix 1 colon 6, n row is 2, and then I can give by row. So you always have these helper functions which allow you to pull out the values. So for example, I do this, and then I can do a control enter. So now if you see, you have the values 1, 2 and 3 in your first row. So when we pass a matrix function to a vector that is too short to fill up an entire matrix, then something different happens. We can have a look at this. So say you pass a vector containing value 1 to 3 to the matrix function, and say explicitly you want a matrix with 2 rows and 3 columns. How do we do that? So for example, I can say matrix, and here I can say 1 is to 3. Now I can give n row, and then I can give the number of rows which we want is 2, and then I say n column, and this one I'll say 3. So I can do this, and here what I have done is I have given the values 1 to 3. I have said number of rows is 2 and your number of columns is 3. So here R fills the matrix column by column and simply repeats the vector. Now, if you want to fill using a 4-element vector in a 6-element matrix, in that case, obviously, R will generate a warning message. Now, apart from the simple matrix function which we are seeing, you also have some functions such as rbind and cbind, which are offers when you are working with matrices. So we can use those. So for example, I could say cbind, I could say 1 colon 3, and then I can say 1 colon 3, and that's my cbind, that is column bind, where I'm passing the values 1 to 3 and which are stacked in columns. I can also do rbind, and similarly we can be passing in the values. So I can say rbind, and that basically arranges the values row wise. So be creating a variable, for example, let's say n, and let me create a matrix here. So I'll say matrix. Now that will contain 1 to 6, and I can say by row, and then you can give value which is true, and then I can basically say the number of rows is going to be 2, and this is also fine. So let's look at the value of n here. So you basically created a matrix with 1 to 6. You arrange them row wise, and the number of rows what you have chosen is 2. So what we can also do is we can use rbind and we can add values to it. So for example, if I want to add values 7 to 9, what I can simply do is I can do a R bind. I can say I would want to edit my n and then pass in the values. So I can just do this, and this has basically appended or added values to existing matrix. So similarly, you could have done a column bind and you could have added values to your existing matrix. So for example, if I take this one and look at my n, and what I could do is I could do a C bind, and then I can basically take my n and then pass in values to this one. So let's say 10 and 11, and basically I've added 10 and 11 as a column to my existing matrix. So this is one simple way where you work with a matrix and you are appending the values either at a row level or at a column level. So let's also look at some other examples. So basically, if you would want to work with matrix, one of the useful things would be naming the matrix. That is, in case of matrices, we can assign names to either the columns or the rows. If you don't do it, we see the default values here, which follows a numbering. But what we can also do is we can use two functions here. One is row names, or you can use column names. So these are the two functions which can be used. So for example, let's do a control L. Let's try to get our n, and this is what we are doing here. But what we would want to do is we would want to give them some names. So for example, I'll say row names, and then I will basically pass in a vector which has row names or vector which has column names. So what I can do here is I can say I would want to give row names to n, and then I basically give some value. So for example, let's say row 1, and then let's say row 2, and now I can look at my n, which has the row names assigned to my rows. Similarly, I could have also given column names. So all I need to do here is I need to say column 1, and then I will say column 2, and then I can be using column names. And let's look at this one. So what went wrong here? So we have 3 columns here. We forgot that. So we have to add one more column name, and then it should be fine. So now if you look at this one, we have just given row names and column names. So naming the columns or rows in your matrices can be very useful. Now, as the previous error says, there is also a function called dim names, and that's basically an argument of matrix function which can be used. So we could also do something like this. So for example, I have dim names. So let's have our n, and then what you can do is you can do a dim names, which you can then just create a list, and in this one you can pass in a vector for row 1 and then vector for row 2. And what we can do here is once we have given this, let's give a comma here and then give C, and then give your column names, which is column 1, column 2, and then basically column 3. And now if you just look at dim names, so you can just see that you have given some row names and column names, and this can be used basically to assign to your list. So if you try to store different objects in a matrix, what would happen? Coercion would take place, right? So for example, if I have X, and let's basically try to create a matrix which will have 1 to 8, and let's say the number of columns is going to be 2. So let's look at our X, and this has the values. Now what if I create, say, L, and then basically I will create a matrix which will be a matrix of letters. So let's say letters, and then here with letters I'll say 1:6. Now I would want to give the number of rows, and let's give it say 4, and let's say number of columns, and let's give it 3. And now let's look at the value of L. So it has letters and X is having numbers. And what if we bind them together using cbind, which is for column wise binding? So for example, if I do a cbind and then pass in my X comma L, so if you see here, there is a coercion which has happened where everything is converted into characters. So you can always do a class and you can check. So this is a simple example of working with matrices. There are much more. You can do subsetting like what we saw in list, but that we can learn later. Now let's learn about data frames and what is a data frame and how do you use R to work with data frame. Now data frame is used to store the data in the form of a table, and for this we have a function data.frame to create a data frame. So what we know already is that data sets are comprised of observations or what we call as instances or variables, and we always have observations to which some variables are associated. For example, we can talk about data sets of say 5 people. Now let's look at the information here. Here we look at the body mass index BMI, where we are using a data.frame function, and then we are passing in say gender. So we use the C function to pass in the values, and then you have height, and then you have weight and age, and these things then become the columns of your data frame. So for example, if we would want to work on creating a data frame for people where let's say each person is an instance and properties about each person such as name, age, child, or if the person has a child would become the variables. So if we have such kind of information, we cannot easily store that in matrix or list. Now data frames can be used for such cases. Now, it's a fundamental data structure to store data sets, pretty similar to matrix as it has rows and columns. And here, rows correspond to observations. Now, here we can talk about an every individual or every person. Columns correspond to variables, that is properties for each person. Now, difference between your data frame and matrix is that data frames can contain elements of different data types. So for example, we can have one column being character, other being numeric, and yet another being logical or numeric. So restriction is that elements in one column should be of the same data type. Now, how do we work with data frames? Let's see some examples. So what we can do is we can bring up our R. So when we talk about data frames, usually we don't create data frames by ourselves. We import data from data sources such as CSV file or RDBMS or even your Excel or SPSS, and then we create data frames. Now, of course, R has ways to manually create data frames using data.frame function. So we can create 3 vectors first, and then we can pass in those vectors to create our data frame. So let's do that. So let's say name, and here I will use the assignment operator, which we have learned earlier. And then I'll use C, and then I can give some names here. So let's say John, and let's say Peter, let's say Patrick, and let's say Julie, and let's also give one more name. So let's say Bob. So this is the vector which we are creating, and we can check this is the vector which we have created. Now obviously you can do a class and you can check what is this, and that says it is a vector of character. Now similarly we can create one more vector which is age, And let's give some numbers here. So for example, let's say 28 and 30, 31, 38, 35, and these are the values for the age. So age is also created. Similarly, we can say if each person has children, so we can say children, and then I'll create one more vector, and here I'll give values which are logicals. I'm not going to give any numerics or character, but I'm using logicals here. So if a particular person has children or no. So let's have this vector created. And now we have three vectors, that is name, age, and children. And we can use this to create our data frame. So we can just call our data frame as df. And what we can do is we can use data dot frame function. And then what we can do is we can pass our vectors within this, such as name, age, children, and that should create my data frame. Let's have a look at this. And this shows me that the data frame is created. Now column names are inferred from variables which are passed to data.frame function. So the variables which we have passed to our data.frame function is name, age, and children, and those become the column headings for my data frame. Now what we could have also done is we could have created it in a different way. So I could have said df, and then I could have used my data.frame function, and in data.frame function I could have said name is going to be name, age would be age, and then I could say children could be children, and I could do this. And this is also one more way where I'm creating a data frame, and in this way we can now have rows of data frames like in matrix. So this is also one way of creating a data frame. To look into the data frame structure, we can always use str, and then we can pass our data frame, and this basically prints out similar to that of list. So we also need to know that under the hood data frame is a list, and in this case this is a list with 3 elements. So each list element is a vector of length 5 corresponding to the number of observations. If we create data frame with vectors not of same length, we would get an error. Now here, when we look at our data frame, we know that name is a column. So name column, which is character, is actually a factor instead of character. To suppress this behavior, we can always use a property, that is strings as factors equals false. So what I can do is I can do a data frame like this, use my data.frame function, and then basically we can pass in our vectors, that is name, age, and children. And then what I can do is I can say strings as factors and set this value to false. So if I do this, and now if I look at my data frame structure, sorry, yeah, now let's look at this one, and this one shows me that unlike your earlier one, now we are creating a data frame where our name would be containing characters. Earlier also by default it was showing as character. Usually if you, because this value by default is set to false, or it would have created characters or factors as we say. Now how do we do a subset and extend and sort data frames in R? So as we have learned so far in brief about your data frames, so data frame is somewhere like an intersection between matrices and lists. So if you would want to subset a data frame, we can always use the square brackets, and in that we can use the single square brackets which are from matrices, or we can use double square brackets from list, or we can also use the dollar symbol. So that all these things can be used to subset a data frame. So let's use our data frame which contains information about people. So we can select single element from our data frame. So here what we can do is we can just say df, and then I can use a single bracket, and I can just do a 3, 2. So it would be good if we can first print the data frame, and that's my value. And now let's do a single bracket and let's look at this one. So this tells me that we are using the row index first, which is number 3, which shows me that we would be going to the row number 3, and then we point or pass in our column index, that is number 2. So we could have done it in a different way also. So we could have done df and then give a row index and then give the column name which you are interested in looking at, and that also gives me the value. So just like matrices, we can choose to omit one of two indices to end up with entire row or entire column. And for example, if we would be interested in looking for information for Patrick, what I could have done is I could have just done df3 comma, and this is showing me the entire row. Now always remember, whatever results we see here, that is giving me a data frame with a single observation, because there has to be a way to store different data types, and that's why the result is also a data frame. What we can also do is to get entire age column, we can just use our data frame, and then we can pass in the column name here like this, and that gives me just the column. Now here the point to notice is result is a vector because columns contain elements of the same type. In previous example we were seeing a row, and in that row was not a vector, it was a data frame because values were of different data types. Now subsetting a data frame that results in a data frame and contains multiple observations can also be done by doing something like this. For example, I will do df, and then I will say let me get 3, 5, and then I can just say age and children, for example. So let's say age and children, and I can be pulling out the values in this way. So I could also be just getting the results in the age column if I'm interested in by just saying df, and here I can just pass in the column number, and that also gives me the age column. Now we know data frame is a list containing vectors of same length. This means we can use list syntax to select elements also. And what we can do is we can use our dollar symbol and then choose the column name. And this is also one way wherein you can pull out the values, or you can use double brackets as I mentioned earlier and pass in the column name. So that's also fine. Or you can give a column number, and that also would work. And in all these cases, result is a vector. Now with single brackets, you can still do it. Always remember, if you use single brackets, then that will result in a data frame. The result can be a data frame here, but what we are seeing here is a list which contains only age column having the data elements. So these are different ways in which you can do a subsetting of a data frame. Now using single brackets or double brackets can have serious consequences. So we need to always think about what we are dealing with and how are we handling it. Now what we can also do is we can extend our data frames. That is, we can add variables, we can add columns, that is adding variables, or we can add rows which are nothing but observations. So adding columns is like adding new elements to the list, and for which we can obviously use dollar or double brackets. Say for example, now this is my data frame, and if we would want to add height whose information is in a vector, so let's say height, let's create a vector here, and this one is what I would want to add for each person. So let me do this and let me pass in some values here. And the last one, something like this. So this is a vector created. Now what I can do is, so our data frame is called df. So we can say df dollar height, and then I will pass in this vector here. And now if I look at my data frame, you see the fourth column has been added, and that's my height column. Now what I can do is, I could have done it in a different way. Basically, if I had my data frame, I could have just done df double brackets and then give it a name, and then I could have passed my vector in this way. However, so this is also one way of doing it. We have already added the column, so we don't need to repeat the step. Now what we can also do is we can use a cbind function. And if you remember cbind, that is for column binding. So for example, let's create a weight vector now, and let's pass in some values here. So for example, let's say 75, 65, 54, 34, 78. And these are my values of weight. Now what I can do is I can just do a cbind and then pass in my data frame and then pass in this vector. And in this way, I'm just adding columns, or I'm extending my data frames by adding more columns to it. Now, obviously, if we can use cbind, then we can also use rbind to add new rows. So for rbind, creating a new vector won't work, because we need to create a new data frame with one single observation. Remember, row will have values of different data types, so we cannot create a vector. We have to create a new data frame, and then we can add it using rbind. So let me create a data frame here. For example, let's call data frame as Tom, and let's pass in some values here. So I will say data dot frame function, and then let's give name. What we can do is we can give age, then we can give the logical value, then we can give, say, height, and since we have added weight, let's also add weight. And this is my data frame. Now we can use rbind function. So I can say rbind, and then I can pass in my data frame and this new data frame which we have created. And this tells me that the number of columns of arguments do not match. So we will have to check this one. So we have our data frame which has just height, so it does not have the weight. That was only as the result of cbind. So let's create this Tom again without weight, and now let's do a rbind, and let's again check what is the reason here. So this is height, and let me just check this. So to look at this, this is the error we were getting, because I was creating a data frame with 4 columns, and then I was trying to add that to a data frame which had 3 columns. Now, yes, we had done a cbind, and cbind was showing us the 4th or 5th column, but the original data frame only had 3 columns. So what I did here was I did Tom, and then basically I created a data frame with 3 columns which matches with my original data frame which had 3 columns, and then I could use rbind to basically add one more row. So what we did was we used rbind, and rbind was used to add a new row to our data frame. Now, when it comes to sorting or ordering your data frame, say for example, we want to sort data frame by age. Now, how do we do that? So we could easily do sort df and then select our column, and we could just do a sorting. Now, if we do this, it is good, but not really what we need. Now, other clear way of doing that would be using ranks. So for example, if I do a ranks, and instead of doing a sort, I would use order, and then basically pass in my column. So I would say df, and then I would use age. Now in this case, if I look at ranks, it shows me a vector of ranks with rank position of each element. Now if I do a df $age, it shows me the values, and if you look at the ranks, it will tell 21, or here the lowest value is your 28, and that's the lowest value, and that's why we see as rank as 1, and so on. We can look at the ranks. So what we can also do is we can just do a df and then basically use ranks, and we can just look at the result. So this shows data frame, which is a ordered data frame now based on ranks. Now if we would want to do it in a descending order, what we could also do is we could do a df and then use order, and within order I will basically pass my data frame. I will choose my column, and then I could say decreasing equals true, and I could do this, and here this could show me the value. So it says undefined column names. So what I would have to check is what is my data frame here. So we have age, and then what we would have to do is we would have to select a particular column. So let's do that, and here I have just selected the column, and then there is a comma missing that was showing an error. So now we can have the data ordered in a descending way. So there are dozens of packages such as dplyr, data table, which can help you manipulate, filter, merge, and sort your data frames. So this is in brief about the data frames, working with data frames, subsetting them, and also sorting the data in your data frames. Now, one more important type of object in your R is vector, and that really helps us in various ways. So let's see how we work on vectors here. So to create a vector, we can use the C function and pass in the values. Those will be the objects or elements within the vector. And then you can look at the value of the vector, or also at the class of it, which tells me the values are numeric. Now in case of vector, all the values have to be of the same type or belong to the same class, we can say. So here we are creating a vector, looking at the value of it, and then looking at the class, which says the values passed in here are character. Similarly, we can do it for numerics, that is true, false, and then look at the value of this, and this class is logical. Now what we can also do is we can print all the three vectors at once, and here we will use semicolon to separate two or more variables, and we can pull out the values of all the vectors which we see here. Now what happens if we pass in the values which belong to different classes, or you can say different data types? So within a vector, if you do that, there is something called as coercion which takes place, which will convert all the values into one type, and in this case it has converted everything into character. Similarly, we can pass in values wherein we can pass logical and numeric, and in this case it's not going to go for character, it is going to convert everything into numeric. Now if I had done this where I passed a character and numeric, and if you look at this, then it has converted everything into character. So character always takes a precedence if it is one of the values of vector, and you have other values which are not characters, then in that case coercion will happen. There is one more way of creating a vector, and that is by providing a range to your C function. So we can do that here, wherein I said C1:20, and then basically look at the value of vector 7. So it shows me all the values starting from 1 till 20. However, there is one more way. You can use the sequence function to do the same thing. Now I could avoid the bracket, I could avoid the C function, and I can straight away pass a range, and that is also fine to create our vector starting from 1 ending at 25. So what if I want to create a vector with odd values between 1 to 20? Now in this case, I'm going to say how many values to skip or to jump. So I'm creating a variable called odd value. I'm using sequence function, and then to that I'm passing the beginning number, the ending number, and then the skip or the jump. And now if you look at the values, it shows me only the odd values. Well, we could have done the same thing to get even values, and that's not very complicated. So you can start from 2 and then you can do skip, wherein after 2 it basically gives you every second value. So we are looking at the even values, and this is how you can create a vector which is having odd or even values. Now, what if you want to create a vector with 10 odd values starting from 10? So you are basically giving a length. So here you can say from where you would want to start, what is your skip, and then the length of the vector, which tells me it gives me 10 odd values beginning from 20, or from 20 onwards, that is we take it from 21. Now, one of the requirements is always to name the values so that we can access the values either by indexing or by their name which have been passed to the value. So let's see that. So let's create a vector which is called temperature. So variable is temperature, pass in the values to this, look at the values of temperature. Now what we would want to do is we would want to assign these names to each value, which makes it more readable, more accessible. So I can use the names function, pass in my temperature as a vector to names function, and then assign the names to each value of temperature. Now, if you look at temperature, it shows me the names which have been assigned. Well, we could have done it in a different way. We could have created a vector of names, something like this. And then what I could have done is I could have created one more vector such as temperature. And instead of assigning values, we could have assigned the vector to our existing vector. So if you do this, so you're assigning the names vector to the temperature one, and now look at the values, it still does the same thing. So this is where you are assigning names to every value of your existing vector. Now there is one more way, and that is using your sequence. So here I'm creating a sequence which starts with 100 and set to 2020 with a skip of 20 values, or every jump would be 20 values. So let's do that. Use your names function on price, and then what I'm going to do is I'm going to use my paste 0 option, which takes P and then 1 to 7 as the values. So we know paste 0 basically skips the space, and we are going to assign those values to as names to price. And now let's look at our price. So that basically gives me the names as we desire. So these are some smarter ways of assigning names to every element or every object within your vector. Now, how do we perform some basic operations? Let's have a look. So let's create a vector passing in the values, and then you can simply do an addition on two vectors where each element is getting added to other element of the vector. You can subtract two vectors, that is element to element subtraction, element to element multiplication or division, and you can basically perform operations on the vectors. Now, how do we use some inbuilt basic math functions? And that's pretty easy. This is my vector. Now let's do a sum which sums up all the elements. Let's find out a standard deviation for all the values. Let's find out the variance for all the values here. Let's do a product of vector values, find the maximum or find the minimum value. So these are some basic inbuilt math functions which sometimes are useful in our data science or data analysis kind of activities. Now, one more requirement might be comparing the vectors using comparison operators. And this is where I create a vector 1, create a vector 2, and let's find out the values in V1 which are smaller than V2 values, and that gives me the logicals as the response, that is false, true, and false. Similarly, you can do V1 greater than V2, or you can say where V1 values are not equal to V2, or equal to V2. So these are some simple comparison examples. Now I can create a different vector and then I can find out individually if the elements in the vector are lesser than 3 by just doing a V lesser than 3. So it compares each element with this. So you are actually using one scalar value to compare it with all the elements, and you can do that. It gives you the logicals. So you can also be doing slicing and indexing on vectors. And this is very much important when you're storing your data in vectors. How do you access them? So let's create a vector using sequence. Let's give it some names as we have seen in past. And let's look at our price one. So that tells me the name and the values. Now you can access the elements using indexing. So let's get the third element and it shows me 590. Remember, the indexing here starts with 1, unlike other programming languages like Python, where indexing starts with 0. Now I can also get the third and fourth value by doing a 3:4. I can also specify the vector and say 1, 4, and that shows me the first and the fourth position or second or sixth position. So this is one way where you are using indexing to access the elements. Similarly, I can give the names. Now that's where we see the benefit of giving names to every element. So I can use C function, pass in the name, and look at the value for that particular name, or selectively select different columns or different names. Or we can also use this square brackets wherein we pass the names. So sometimes it can also be useful to use logical positioning. That is, we would want to find out the logical position if the value exists, and we can do that, or using true and false and then look at the values. So there is one useful way where you can exclude a particular position. Might be that is an NA value, might be a value which you are not interested in, and that's where you will say -2, which will skip the P2 value, or -2 and -5, where we are skipping a P2 and P5, and we can exclude particular values from our vector. Now, how do we do a comparison operator on the values of vector? So you can just say price 1, and I would want all the values which are greater than 600, or you can assign this to a filter and then basically pass in the filter for your vector. So these are some simple basic operations which you can run using your R programming, where you would want to manipulate, where you would want to store some data and extract that data, use your different logical operators or other operators, and perform your basic easy computations. Now that we have seen some basic operations using R, let's look at some more operations when you're working with vectors, such as one of the common issues is handling the missing values. Now here we are assigning a vector to a variable order detail, and this one has a missing value. Now let's see how this is handled, and you see all the values in the vector are assigned. What you can also do is you can assign names, as we have seen earlier, by using the names function, and then look at the value of order detail. So you see the names, and these are your missing values which are also taken care. Now what we can also do is we can perform an operation on a particular vector which will be applied to all values of the vector. So for example, here I will just add a scalar value +5 to the elements in the vector, and that shows me number 5 has been added to each element or each object in the vector. Now, if you would want to work on two vectors, for example, to add two vectors, let's create a vector called new order, and then let's add it to order detail. Now, in this case, what we are doing is we have a vector which is from 5 to 10, and what we are doing is we are adding values to order detail. Now, our order detail earlier was 10, 20, 30, NA, 50, and 60. And what I have done is I have passed in a vector which is 5 and 10, and you're adding it to the elements. So 5 gets added to 10, and then your value 10 gets added to 20, and Then you have again 5, which is added to 30. Now you cannot add in anything to a missing value, so that remains as it is. Then you add again 5 to 50, and then 10 is added to 60. So in this way, you are adding two vectors which are not of same length, but you are adding these values. Now what I can also do is I can update the order by doing this. So I'm creating an update order. And now let's look at the value of update order. What does it show? So you are basically doing the same thing. So if you would want to work on a subset of vector, how do you do that? So here you are using some indexes. So I'm saying order detail, and this is my order detail. So let's take 1:2 and assign it to first two. So if we look at the value which is assigned to first two, we have just sliced and added a subset of vector to this one. And if I would want to take the length of order detail, it shows me the length here, which is 6 elements here, including the missing value also. What we can also do is we can do some more operations. So for example, from order detail, what I'm doing is I'm saying length minus 1 and then up to the length. So let's do this and let's see the result of this. So what we have done is we had our order detail which had these values, and what we have done is we have said length minus 1 colon length. So you have taken these two elements and you have assigned that to your v1. Similarly, we can do length minus 1 and 2 elements. So I can do this, and now let's look at the value of v2. So this shows me the value where you're taking length minus 1 and then you're taking it till the second position of the index element, which is 20. So you are getting in the values here. So you get your 50, NA, 30 and 20 because you started with length minus 2 and up till the second index position. Similarly, we can use the length and we can take it from this element, and let's look at the value of v3. So that shows me that I'm doing some slicing, or I'm getting subset of my vector. So similarly, you can also do this one. So v4, and let's do this, and then let's look at the value of v4. So it gives me the values based on our subsetting or slicing. Now you can extract all the values below 30, and this is where you are doing a comparison. So you will take your vector and then you would want to compare each value if it is less than 30, and you would want to take all the values here. So it gives me the logicals or the response for all the values which are lesser than 30. What we can do is we can also use the square brackets and do this. This will show me the actual values. Here we were just getting the logicals, but here we are getting the values. Now to omit NA value from the vector, we can use NA.omit, and this one will help me in getting rid of the NA values. Plus I'm also checking the values if they are less than 30, and then I am basically doing using this NA.omit. So you can do something like this. You can look at the values. What you can also do is you can find the order details that are multiples of 3, and here we would want to use modulus, and we would want to find out if the remainder is 0, then I'm getting the numbers which are divisible or multiples of 3. So let's do this, and it gives me again the logical values of all the values which are divisible by 3, giving us a remainder of 0. Or if you would want to look at the values, then you can say order detail, open up a square bracket, and then pass in your condition. Now we can then omit NA from this one, and then we can look at the values. So this is a simple way where you are subsetting a vector or extracting the values which you are interested in, which might be one of the requirements of your data wrangling or data manipulation or just data extraction. Now I can also use a sum function. Now if we do this, it returns NA because there is already a missing value and you cannot do a sum on the values. Now what I can do is I can do a na.rm to remove the na values. So I can do a sum on order detail where I intend to add up all the values. But what I also want to do is I want to remove the NA value. So I'm giving it a value as true. And then if I do it, it gives me the sum of all the values. So similarly, you can do a mean, you can do a maximum, you can find out the minimum value, standard deviation, or even square root. Now these are some simple operations what we are doing on vector where we are interested in extracting some specific values. Now, let's look at matrix, which we have also discussed. And matrix is also one way where you can use the matrix function to create a matrix which is multidimensional. So for example, if I do this and if I look at the value of V, I get a matrix which starts with the value of 20, ends with 30. And at any point of time, you can convert this to matrix. So first we created a vector and now I'll create a matrix out of it wherein I am seeing the row numbers, I'm seeing the column number, and I'm seeing the values in that particular column. So you have already done that. Now let's take it to the next level. So let's create a matrix wherein we are using the matrix function. We will say 0, 3, 3. And now let's look what it has done. So you have created a matrix which is of 3 columns and 3 rows. And by default, the row number and column numbers have been assigned to them. We can also create a matrix by passing in values. So we can say 1, 9, and then give the dimensions, that is number of columns is 3, number of rows is 3. And if I look at the matrix, now I have passed in the values to my matrix. So sometimes you may want to arrange the data in a matrix for particular kind of calculations. You can also use n row and by row. So you can say how many number of rows you would want, and you would want to assign the data row wise. So when we are doing this, now if you notice the difference between the previous one where we just gave the values and we said 3 rows and 3 columns, so it was doing it column wise, so 1 2 3 4 5 6 7 8 9. But here we said by row is true, so it has arranged the values in a row wise fashion. So it goes 1 2 3 4 5 6 and 7 8 9. Similarly, I could have just done this by giving the dimension and selecting by row. And if I do this, it is still doing the same thing. Now, what we can also do is we can create matrix using vectors. So here, let's create a vector stock 1 and then stock 2. Now, we would want to merge both the vectors. So you can always do a C function and then create a new vector that is stocks, which is a merged result of stock 1 and stock 2. And let's look at the result. So that's my stocks, that's a vector. And now what I would want to do is I would want to create a matrix using this stocks. So I'm giving it a name that is stock.matrix. I'm using the matrix function wherein I will pass my vector. I will say by row. So I want the values to be arranged row wise. And I'm also selecting the number of rows. So if you look at this one, so the values which we had in our stock, which was all the values, have now been arranged row wise and in 2 rows. So it starts with 450, 51, 52, 45, and 68. That's my first row. And the rest 5 values are arranged in the second row. So one of the main requirements is instead of going for default column names and default row names, we can give specific names to our columns and rows to make more sense to the data. How do we do that? So we can basically say days. So this is a vector which we are creating. And then what we want to do is we want to create a new variable, which is stock 1 and stock 2. Now, this is for my columns and this will be for my rows. Now, how do we assign that? So we can say column names, and this is where I will say on my stock.matrix, I will assign days, which has 5 values, and that will become my column names. And similarly, using row names function, I can basically assign row names to my matrix. So if I look at my matrix now, it shows me the column names and row names which we have assigned or which we have passed to our matrix. Now, there are different functions which are associated with the matrix, and let's look at some examples. So these are some simple basic examples. Now, if I say, let me find out the number of rows, and that gives me the number of rows or number of columns, or get a dimension, that is the number of rows and columns of your matrix. Now, we might be just interested in getting the row names or column names or even the dimension names, which basically will give me, returns the row and column names. So in this way, you can use these simple functions which are associated with matrix to extract information about your matrix or data which has been transformed into matrix to pull out some information about that. One of the requirements which data scientist or data analyst might face is carrying out arithmetic operations on your matrix. Now what we can do is we can create a matrix which takes values 1 to 50. We want to arrange it by rows, and we will say number of rows is 5. So that's my values starting from 1. Now I can do a addition here by just doing a 5 plus mat1, and if you notice, number 5 as a scalar value has been added to every element of the matrix. Similarly, you can do a multiplication, you can do a division, you can basically return the quotient if you would want to do that, or go for exponential values. So you can perform simple arithmetic operations for every element of the matrix. And what if you want to have arithmetic operations done on multiple matrix? So let's create mat1 plus mat1, and we get a total where every element is added to every element. You can do a subtraction, you can do a multiplication, and you can get the value. So this might be also very useful when you're working on multi-dimensional data. You can also do some more operations on matrix, such as returns the sum for each column. Say you are doing a summation or at a row level, or you want to do a mean for every row, you can do that by using these simple functions. Now you can add rows and columns to a matrix using rbind and cbind functions. So rbind is for row bind and cbind is for column bind. But for that, we have to first create a vector. So let me create a vector of same length, which will then be added to every, or added as a row to my existing matrix. Now my matrix has 5 columns. So let's create a vector with 5 elements. And then I can basically add this as a row to my existing matrix by doing this. And now if I look at my values, I will see the new values as the third row. And if you also see, the variable name becomes the row name, and we have added a row to our matrix. Now similarly, I can find out row means, that is we have seen earlier, by calculating the mean or average. So I can do that, and I can find out the value of average. Now what I can do is I have got the average for every column, and what we can do is we can basically do a column bind by using a cbind function. And I will say I'm going to take the total stock, which has 3 rows, and then get the average. And now let's look at the total stock, which shows me the average value, which is the new column which has been added to the matrix. So these are some simple, very simple operations which you can do, but that gives you good insight in what can be done at a matrix level where your data is arranged in multi dimensions. Now, how do we do a selection and indexing in matrix? So in vectors, we were using either names, or we were using positions, or we were using indexing. Now here, let's create a matrix called student, and we are using the matrix function. But within the matrix function, we are using the C function to create a vector, which will pass in all the values, which also has NA values if you closely notice. We will split these values into number of rows is 4. So that means the values, the number of values in this vector should be a multiple of 4. I'm saying columns is 4, and I would want to arrange this data row wise. So I've done that. And if you would want to get the dimensions out of this, so I can do a dim names. So what I'm doing here is on my student, I'm assigning a list which will basically have these names which are basically assigned. And now if you look at your student, it basically shows me the values which were first applied to the row names, that is John, Matthew, Sam, and Alice. And then you have one more vector which goes as the column names for the values. So you have not only created a matrix by using a vector, by defining your dimensions, that is number of rows and columns, you have arranged the data in a row order. And what you have also done is using a list function, you have passed in the values which will be applied as row names and column names to your matrix. Now, how do we extract particular columns here? So we can take our matrix and we can just say comma 1, and that basically gives me the values for John, Matthew, Sam, and Alice. And what we are looking at is the first column. Now I can also say from first column onwards, I would want to look at how many columns. So I can do this. And now here I'm selecting first and second column. I can also be using a vector function here, and that also does the same thing where I'm saying 1, 3, and I'm getting the values from first and second column. So third is not included here. Now, if you would want to do row wise, then you have to give the row position first. So if I do a student 1, that gives me the row values. And this is giving me values for my student, which we are seeing here. So for John, we have 20, 30, NA, and 70. And that's what we get here when you do a row wise operation. You can also do a row wise and how many rows do you want. You can use the vector function to do that. You can also select or slice out a value where you are getting an intersection of row 2 and column 2. And then you can also start from a particular position and then onwards get your rows. So these are different ways in which you are slicing the values from your matrix by columns or by rows. So at this point of time, let me just type in student here and let's look at the value of student. And then here we are interested in 3 colon 4 and then 2 colon 3. So what does that give me? So you are looking at third to fourth row. So you're looking at Sam and Alice, and then you are looking at columns 2 and 3. So that basically gives you your 26, 32, 24, and A. So first is you're giving your row positions or how many rows you want, and then you're giving your column. So similarly, you can do this. You can say from row number 2 to 4, and then column wise, you can say 1 to 3. So if we do this, so this tells me 2 columns, which is first and second, and it shows me rows, which is from second to fourth. So in this way, we can extract data based on rows and columns. Now, if we would be interested in finding out a specific value, so for example, if I again bring up student, this is my student, and what I would be interested in is getting the value of John and for specific subjects. So might be we are looking for 2 colon 3. Now if I do this, it shows me for John, and what we are interested in is 2 colon 3. So that gives me the value for chemistry and biology. So you are giving the columns. So row wise, you have already specified the name, and that basically selects the particular row. I could have given a number and chosen which row or which rows we would want to pull out the values. Now, if I would want to find out the value for John and Sam, now in that case, I could use indexing or positioning, but that has to be continuous. But here you're talking about John and Sam, which has Matthew in between. So we will basically we will get the values for John and Sam, and then we will look at the value 4. Now that is basically giving me the values in the fourth column, which is 70 and 75. Similarly, if you go further, you can look at maths and bio score of Sam and Alice. So you will give your row names, that is Sam and Alice, and then you would want the values for maths and bio. So that is basically your third and fourth column, and we can do that by looking at the values. How do you find out an average? Well, that's pretty simple. You can use the mean function on student. You will select your row name, that is John. You also want to get rid of NA values, otherwise that will give a problem. So you get rid of that by saying NA.rm equals true, and then you get the average score of John. Now, how do I do further computation? That is, if I want to find out the average and total score of all students. So in this case, I can apply, or I can use an apply function. Here, I'm saying I'm working on student, and we would want to give the row number, that is 1, and we want to also give the column. So I want to find out mean. I want to remove or get rid of the NA values. And now if I look at help apply, it tells me how does the apply function works over array margins. So I will do an apply function on student, where I would want to select the first row. I would say I want the sum, and I want to get rid of the NA values. So this gives me the sum for each student. And here we are getting a mean value, which was for each student. So what we are doing here is, for example, let's look at student again, just so that we avoid confusion. So we have student, and then we have physics, chemistry, bio, maths, and I have said row 1. So basically what we want is, for John, we want the total. And what we can do here is we can say 20 plus 30, avoiding NA, and then 70, that gives me 120. Then you look at Matthew. So this is again doing a totaling. There is no NA value, and you look at the value, right? So when we have chosen apply function, we have worked on student. Now here we are interested in the values, that is sum of all the values for this particular row. I'm saying take care of NA and then give me a sum. Similarly, you did a mean, and that was giving you a mean for each student. So these are some simple operations. Now what we can also do is we can basically create a vector called passing score. And what we would want to do is we want to get the values, or find in how many subjects Alice has passed. How do we do that? We will have to compare Alice score, which should be greater than or equal to the passing score. So what we can do is we can create a variable here, pass. Now I'm saying student, I would be interested in the values for Alice. So I've mentioned that row name here. I'm then comparing it with passing score, which we have created here, and that will give me the values wherever Alice has passed in a particular subject. Now I can obviously get rid of the NA values and then look at this, which basically tells me there was one subject in which Alice passed and rest were either false or NA. Now same thing we can do for Sam. So Sam is here, and what we want to do is we want to look at the values here. So we will say let's do the same thing for Sam and find out the comparison with passing score and get rid of NA values. So you are basically extracting values. So these are some easier operations and usage of functions on your matrices, which are filled in with values at row level and column level, and then you can apply one of these functions or multiple functions to basically extract value, which makes more meaning. So that's with your matrix. Now let's also look at data frames. Now data frames, as we know, is basically data which has been ordered in rows and columns, wherein we can assign row names, we can assign column names, we can do some operations on data frames. So let's look at example. So if I do a data here. So that gets me some sample data sets or functions what we have here. So let's do, once we have our data here, so it says use data package, and then you can get list all the data sets in available packages, and you can basically look at all the R data sets which we are seeing here. It has opened up. So I would be interested in getting the air passengers data. So I'm going to pass that in the data function. And then if I do a head to see the initial data from air passengers, it shows me the values what we have. Similarly, we can do that on iris data set and look at the head values. I can do a view to look at specific values in a tabular format if that makes more meaning and that makes it easy for analysis. Now I can do a view on state X77, and that basically shows me the population and income and all this for different US states. So these are some different data sets what we have. You can do a view on them to basically understand the data or look in a more readable format. You can just do a tail to get some end data. So head and tail functions just give you the top 6 entries, or basically your entries from that particular data set. Now the question is, how do we work on this data? So I can get a statistical summary. So I have the iris data set which we had here. So if I do a head, it shows me iris data set. This is a popular data set which shows the petal length, sepal length of particular flowers and the species, what is the length, what is the width, and what species does that flower belongs to. Okay, now here we can get a summary, that is statistical summary of a data set, which gives me mean, first quartile, median, mean, third quartile, and maximum values. It basically shows you the count of the entries for each species what we have under the species column. Now what I can do is I can check the structure of this data set using str. I can create a data frame now of this data using the data.frame function. So for that we need to also have, say for example, if we would want to create a data frame, let's see how do we do that. So first we create a vector of days, we can create a vector of temperatures and rain, and then we want to create a data frame out of this. So I use the data.frame option. I pass in my days, temp, and rain as the vectors. And now if you look at the data frame, you basically see that I have my days, my temp, and rain. So those were the variables, those were the vector names, and those have become the column names. Row names are auto assigned, and basically we are seeing the values which have been passed in my data frame. Now I can do a summary on this to basically look at what is the length or how many values we have in data frame, what is the class of elements, so that is character. You are looking at your values or summary which gives you mean, first quartile, median, mean, and so on. And then it also shows you the complete data on rain. What is the mode here, how many false or how many true values we have. You can also look at the structure of this data frame by doing a str, which gives me how many objects we have, how many variables we have, what are the different variables, so that is days, temperature, and rain, and the values for those. For days, if you notice, it is of the type character, temperature is numeric, rain is logical. Now how do we do data frame indexing? So like your matrix, which basically has rows and columns and in multi dimensions, similarly in data frames also you have indexing. So you can do a data frame. So I could just extract the first row by doing this, and that basically gives me the value. So you can always compare it by just typing a df. So that's my data frame. And now let's look at the values. Extract the first row, and that shows me Monday 25.6, rain value is true. Now I can also do it column wise. So for example, I could do it in this way. So here what I'm doing is I'm doing extracting the second row from this one. So it tells me 25.6, 30.1, 40.0, 37.3. So you have extracted the values for the column, right? So I would not say extract the second row, you would say extract the second column. Okay, so this one should be second column. Yeah. Now selecting using column names, so that's the easiest way to extract the values for a particular column. So I can just do this. Instead of giving the position of the column or the column number, I'll give the column name, and that gives me all the values of temperature. And if I do this where I'm saying 2:4 and then I'm giving the columns, so it gets me the second, third and fourth rows for day and temperature. And we are looking at the values. So you have given your row names and then you have selected your columns. You can also do a $sign if you would want all the values of a particular column. So I can just do a df $days or df $rain, and it shows me the values from my data frame. Now, one more way of doing that is using your bracket notation to return a data frame format of same information. So if you want the resultant data in a data frame format, you can just do a df rain or df temperature, and that is basically giving a data frame. So if I had assigned this to a value, and if I had looked at the type of this, that would be data frame. Now, one of the things which we also require is filtering data frames using a subset function. So that is subsetting the information from a data frame. So we know we have our data frame. Let's look at our data frame again. So that just reminds of what data values we have. And here, let's get a subset out of it using the subset function. So I'm passing in my data frame. I am saying I would be interested in the rain column. So I'm giving subset rain column, and wherever the values are true. So returns all the columns where it has rained. Similarly, I can do a subsetting by giving a value for temperature wherever the value is greater than 25, and that shows me the value. So this is where you're filtering the data in data frames using a subset function to which you have to provide a column name and then giving a condition. Now, one more important thing which might be required is sorting your data frame using order function. So I can create a variable by name sorted.temp. I want to do a ordering of data frame, and here I'm doing a ordering based on temp. And now if I look at the value, or I can create this in an ascending order. So let's look at the values. And now if I look at my data frame, it just gives me the order or the ranking for the particular values. So we have discussed this in other section also. So what I can do is I can return all the columns with temperature sorted in a descending order. So right now what we were seeing was we were seeing in an ascending order, but what we can do is we can do that in a descending order. So here I'm creating a variable descending.temp. I'm doing a ordering, but when I'm doing a ordering, I'm using the minus symbol. And this one, if you would look at in the form of a data frame, it shows me the values which are ordered in a descending order based on the temperature column. Now, another way of sorting is by using a particular column. So what I can do is I can sort, I can do a order, and then I can choose the column based on which I would want to order it. And then if you would want to get the values of this, so it tells me the values have been ordered based on temp. So this can be very useful when you would want to sort the data or order it in a particular way to basically understand your data or to make more meaning out of it, right? Similarly, one more requirement might be merging your data frames. So here I'm creating a data frame. So I'm saying authors, and I'm using data.frame function. And what we are doing is, instead of creating 3 vectors, I am basically doing that within my data frame function. So let's do that. And now what we can do is at this point of time, I can check what my authors look like. So this is my authors. Now here, if you see, we have the vector Turkey, Venables, Tierney, Ripley, and McNeil. So that becomes my first column, which is surname. Then you have your nationality, and then you have deceased, where you have also repeated the values 4 times, right? So that's something new which you might be seeing. So you are creating a vector where you are passing in a value, and for other set of values you are basically using a repetitive function. Now similarly, we can create a data frame called books, and this one is where I am having name column, title, and then I have other dot author, and you are passing in the values. So at this point of time, if you would want to look at your books, it would look something like this. So you have given a name. Now just closely look at the data frame function. So here you are using the names, you have the titles, whatever values you are passed in. Always remember, when you have multiple vectors, they are ending with a comma, right? So do not forget that. And then you have other dot author, so that's the name of the column, and you are passing in the values, where you have also passed some NA values. And at this point of time, you can look at authors. This is your books, and our intention will be to merge these data frames. So that's what we would want to do. Might be we are interested in getting the data together. So what I'm doing here is I'm saying M1. Now I want to use the merge function. I pass in my data frames, that is authors and books. So if we closely look at authors, it has 3 columns and 5 rows, and here you have 3 columns and we have 7 rows. So we would want to do a merge. So we'll say authors books, and we will say by dot x. So this is where I'm choosing which is the column based on which I would want to merge. So I have by dot x, which is surname, and by dot y, which is name. So we would want to merge the data where we are giving a condition based on values in surname and name. So you see there is Turkey here, there is Turkey here, we have Venables, we have Venables, we have Tierney, we have this one, we have Ripley, which we have here, multiple entries, and then you have McNeil. Now we don't have R core, which is there in your author. So let's see what happens when we do a merging here. Okay, and now we see the result of this merge, where it has taken all the values from both the data frames. So you have surname, nationality, deceased, you get the title, you get the other dot author, which you are getting in from your books, and the name column is avoided, right? Because we are doing the merging based on surname, and but y dot name is name, so we don't see the name column. But what we are seeing here is the values which have been merged, and then you can compare. So for example, let's do a random check. So if I look at McNeil, that's the surname, or here it was name. So you have McNeil, you have a nationality which comes from the first data frame, deceased from the first data frame, then you have your interactive data analysis, and then you look at title.author. What you don't look at in the merge is this R core, because this does not have any value in your author's data frame. So you can do a merging of your data frames using the merge function. So please try it out, and you can create different data frames and try to use this. Similarly, you can manipulate a data frame. So for example, here we are creating one more data frame called sales report, which is data.frame. You are giving an ID, product has some values, unit price is where you are getting the values as integer, and quantity as integer. So now if I look at my sales report, this is the values which I have. Let's spend a couple of seconds to look at this value. So ID value is 101 to 1010. Product is A, B, so that is automatically assigned. Unit price is starting where you say 101, 140, 184, right? So we are using a as dot integer, we are converting it into integer, and basically we are assigning these values here for your unit price. And similarly for quantity, we are assigning the values by doing a as dot integer and then just doing a run if. Now once we have done that, we have created a data frame Now, how do you transpose? What do you mean by transpose? So transpose is when you are changing your accesses. So if I do a transpose on sales report, and if I want to do a view, so you will see the positions which have changed. So you have all these values. So my row names or row whatever values become the column headings, and basically your column headings becomes your row names. So that is what you're achieving by doing a transpose. You can do a head to look at some initial values. You can do a sorting of this data frame by using the order function, and you can choose the column and also the order if you would want to have it in ascending or descending, or basically increasing or decreasing values. You can also choose a particular column, like we are choosing product as a column, and I would want to take the values of sales report in a descending order, that is unit price, and we can just do ordering of data frames or sorting the values in data frame. So this is pretty easy. Please spend some time in practicing these things, taking these examples, and you will learn more about these functions. You can always try creating an example at your end, and you can try to look into these. Now, what about subsetting the data frame? So when you're saying subsetting the data frame, let's do a subset function like what we used earlier. I will say subset.product A. I'm using the subset function, and here I will get the subset based on the product value being A. Let's look at this, and this shows me only the values where product value matches A. Now extract the rows for which product is A, and unit price is 150. So you are still doing a subsetting, you are still passing your data frame. Here you will give the product is A, which will tell basically the values for product, and unit price greater than 50. So you're giving some conditions and look at the values. Now, if you're only interested in particular columns, so if I say only the first and the fourth column, product is A and unit price is 150. So you have to still use your subset function, pass in your data frame, product will be given as A, and unit price should be greater than 150. But what I'm interested in is the values from the first and the fourth column. And now if you see, it shows me the values for my fourth column. What we can also do is we can create two subsets. So set A from data frame, where we take the product as being A, other one is being B, and then we can look at the values. So this is just A, this is just B, and what we can do is we can combine them, or we can merge them using column bind. So when I say column bind and I'm saying set A, set B, so it is basically going to stack the data frames column wise. And if you do R bind, it is going to stack the data frames row wise. So we can either use column or we can do a row wise. So this is in one way where you can merge. The previous example where we saw merging was based on a particular condition which is met based on some columns which might have similar values, right? And this is where you are straight away merging the data frame using column bind and C bind. So if you compare this with the other merge operation, what we saw here, this was where you are comparing the values of first data frame and second data frame and then merging. But here we have just used column bind and row bind, so we are not merging on a particular condition, we are just stacking them either column wise or row wise. Now what we can also look at is doing some aggregate operations. This is going deeper into data frames. So when you use an aggregate function, you are passing in your data frame, you are choosing the quantity column, and then you are basically using the list function. So list function is going to work on your data frame on the product column. So product column for your sales report. So at this point of time, let's look at sales report. And let's look at the value here. So this is my sales report. And what we want to do is we want to aggregate the values on quantity column. But for that, I will say, I will just take the product columns and I will get a sum wherein I'm ignoring the NA values. Let's look at this, and that gives me an aggregation value. So remember, aggregate function is doing a summing up. Now here we are doing a summing up on your product, that is sales report product column is what we have. So you are kind of grouping by based on product. So we have two products here, A and B. Now what we also want to do is we want to take the quantity column. So that's why we have given that first. And what we are doing is we are doing a summing up. So we are summing up all the values for A and all the values for B. And we are seeing that here, if there are any NA values, we are ignoring it. So these are some basic operations on data frames or matrices, subsetting them, extracting useful information, using some inbuilt functions to do transformation or computation and extracting some values. Now, similarly, we can also work on lists. Now that we have looked at data frames, matrices, vectors, let's also look at one more structure and how we work in R when we have to work on lists. So list is basically a structure here, and what we are doing is we are creating a list by using the list function. And here I am passing in three vectors you see here. Now C function is being used. Now in vector we know that all the elements are of the same type. Now let's create a list wherein we see three vectors which are of three different types or objects of three different types. So let's create this list. And now let's look at our list. So it basically has elements wherein you have values of different types. We can create a different list which can also have sequence elements, that is 1 to 10, a matrix which is of 3 dimensions, and then also passing a list. So this is also one way of creating a list. Let's look at list 2. And if we look at the values here, list 2 basically has a vector which has values 1 to 10. It has a matrix of 3 into 3. It has a list which has values A having 10 and B having 20. So this is how you can create a list which can have objects of different types. So we can also use recursive variable, a variable that can store value of its own type. So for that, you have to use a recursive function, something like this. So I'm saying is recursive and then do it on your list. And we can check if the list basically has a variable that can store values of its own type. Now, one of the main requirements when you're working with lists is indexing. So I have created a list and here I can access these elements by using an index. So if I do this, this shows me the matrix. What I could have also done is using the dollar symbol and then choosing particular element of the list by doing a mat, which is the name given to our matrix, or by choosing a name that is vector. So you can access the elements using indexing or dollar notation or giving the name of a particular element. Now I can also work on list and I can get the third element's second value. So we can do that and that shows me 20, or you could have done by giving the value 3, that is the third element, and within that you are looking for second element. So I can get the length of the list, I can get the class of the list, which shows me it is type list. And what I can also do is I can convert vectors into list. So here we are creating a variable price, which is being assigned a vector which has 10, 20, and 30. And now what I want to do is I would want to convert this vector into list. And for that, I'm using the list function. So I am creating a variable called price list. And then I'm saying as dot list. So that's going to convert my vector into list. And now let's look at price list, which shows me a list, or you can look at price, which is a vector. So that's when you're converting your vector into list. Now, how do you convert your list into vector? And that also can be done by doing a unlist function. So I can basically work on price list wherein we converted vector to list, and I can just do a unlist on that, which will convert my list into a vector, looking at the values of the vector. Now, sometimes we may want to get the dimensions. So we can use the dimension function to convert the vectors to a matrix so that it can have multiple dimensions. So here we create a vector which has 4 values, and then I'm going to give a dimension to this so that it is converted from vector into matrix by giving dimensions 2, 2. And now if you look at price 1, it has basically changed into rows and columns of 2 into 2 dimensions. So these are some simple examples of working with list. Now, when you talk about basic data type functions, we have seen how you use the assignment operator, how you get the data type of a particular variable or the class to which it belongs. I can assign different values such as 10.5. So the previous one was showing me the value numeric, and now what we would want to do is we want to assign a value 10.5. Look at the class of it. It says numeric. Type of it shows double. So by default, it belongs to the double class. Now I can check if the values in N1 are numeric, and that shows me true. And similarly for N2, and that shows me 2. So you're using the numeric function, which returns true if the given value is numeric. Similarly, we can have integer assigned to a particular variable, and for that either I can do as.integer or I can assign a value with capital L. So I can do this and look at the value of I1, similarly I2, and look at the values. And if I would want to check if that is an integer, let's look at the values of I2, which was an integer, I1, which was an integer, and I3, which is an integer. So here we have assigned integer values to a particular variable. Now all integers are numeric, but all numerics are not integers. So let's check that. So if I do a is numeric on I1, which was assigned as dot integer 10, that shows me true. If I say is dot integer on I1, so was that an integer? And if I look at the value, it shows me true. Now let's look at the character values. So if we say C1, C2, and look at the class of this, it shows me it is of character type. Similarly on C2, and you can always validate that by using the character function. You can also use some inbuilt functions such as converting to an uppercase or getting a substring from the starting till the position what you would want the elements. I can do a paste function, which basically will give me the data combined, or you can say concatenated. You can also use a paste 0, which we know will get rid of the space and it just concatenates them without a space. I can also use a specific separator, which we have seen examples, and we can do that. And what we can also do is we can replace set of characters. So here I'm saying substitute, and then if I look at the values, it has basically replaced Rob with Senna. And let's look at the length of it or number of characters in this. So these are some basic operations what you're doing on matrices, on your data frames, on your lists, and also on your variables, where either you are assigning them values of a particular type or you are changing the data types. You can also go for coercion. In case of vectors, we have seen that, where if you are passing in values of different types, that's coerced into same types. So later we can learn more on functions and flow control and how that is handled in R. Let's learn how R can be used to take care of flow control. That is, if I would want to have a if else condition, and if what I would want to compute, or if I would want to check some values, how R can be used. So here, if statement consists of a Boolean expression which is followed by one or more statements. So we can just say if, we can pass in a Boolean expression where we would want to compare particular value or we would want to check a particular value, and then whatever is passed in the statement will get executed. So what we can do is here we can use assignment operator. I can pass a value to X. Now we can always do a type of, and that can tell me that x is basically an integer. And now I can use my if, where I can say is dot, and then I can choose integer, and I would want to check the value of x. If that is an integer, then I will just use brackets and I'll pass a statement here. So let me say print, and let's say x is an integer, and we can execute this, and this tells me that the boolean value is true. Now if, for example, we would have done something else, or say for example, instead of integer, if I had used let's say character for that matter, and we can check the value and we can do this. So here we will check the values, and it says there is an error with the bracket, and let's check this one. So if x, because we missed a bracket here, so let's do that one and then try this, and it doesn't show me any result. So how could we handle something like this if the boolean expression does not match to true? And in that case, we can always go for else statement. So we can check for a value. So if the boolean expression is true, statement will be executed, and if it is false, then next statement will be executed. So we could have done the same thing here, where I said print x is an integer, which we know is not true. And what I could do is I can here, after this one, say else, and then I can open up one more bracket, and then I can say print, and I will say x is not a character, and now we know that x is not a character. So this is a simple way where you can use if else, and you can control the flow by passing in the conditions. Now that's when you're using if else statements. Now what about while loop? So that also can be useful when you're programming in R. So an else statement is executed when the condition in the if statement results to false. So that basically means what we can do here is, let's pass in a word or a set of words like this. For example, let's say v, and then we use C function to create a vector, for example, and then I can just say hello world. And if you look at v, you can look at the class of v, it's of characters. And if you look at type of v, it is having the objects or elements as character. Now what we can do is we can basically then say count, and let's assign this a value 2. Now what we would want to check is the count of elements in our v equals to 2. So what I can do is while my count is less than say 5. Now I'm saying I would want to do something while the count is less than 5. So we have already given a value to count as 2. And now what I can do is here I can open up a bracket, I can say print, and then pass the value of v. And then what we do is not only this, we will also increment the value of count, and we will say count plus 1. And here it gives me error, probably because we have missed a bracket. So let's see what we are missing out here. So let's just check this one again. So here it is. We have created v, which has 2 elements of the type character. And then what we do is we assign count a value of 2, and we would want to check while the count value is less than 5, we would want to print the value of v. So what we are doing here is we are saying while, then you pass in an expression which will check the value of count. We do a print, and then we increment the value of count. Now this is a simple example where you are using while to basically test an expression, and while that expression is true, you would be doing something whatever is passed within your brackets. Now we could also be going for loop. Now for loop is basically used to iterate over a list of elements or a range of numbers. So for example, if I have a vector like fruit which has some values, I could just say for I in fruit I would want to print something. So let's try this also as an example to test our for loop. Now we can just say names, and we can basically then assign values to this. So let's say VJ, AJ, DJ, and let's say SJ, and let's create this. Let's look at the value of names. Now what I can do is I can use a for loop, and I can say for I in my names. So I will say for I in names. Now what do you want to do? So open up your brackets here, and then we would want to say print I, and then basically close the bracket. So you see, for every element in this vector, it is basically going to print the name one by one. So you're iterating through a set of objects by using a for loop. Now this is how we can work on for loop. So if else, while, and for loop can be very useful when you would want to iterate, or when you would want to check the value of an expression, or when you would want to loop and do a particular task. It's always good to understand how you manage flow control in R. That is, either when you're working with your for loops, your while loops, also understanding how you can use your logical operators for working with your data in R. So let's look at some examples and understand logical operations. So either you could be having and, or you could be doing a or where you're evaluating one condition, or you're using not. So these are your logical operations. Now here I can assign a value to x, and then I can check if my x value is less than 10, and it shows me false. So I have been checking the value of x. So let's see, is it greater than 10? And that's true. Now I can use logical operations here. So I can say and, so I'm saying, is my x value less than 20? And is my x value greater than 10? Now both these conditions are not true. So in this case, we get the result as false. But if I say x is greater than 20, which is true, and I'm saying x is greater than 5, that's also true, and x is equal to 25. Now, whenever we are talking about and, we have to look at all the conditions have to be right. So let's look at this, and we get the value as true. But if I say x is greater than 10 or x is later than 5, then one of the condition has to be true, which is true in our case. So we get the result as true. We can take a different example. We can say, is x less than 20, which is not true, but is x equals to 30, and that's also not true. So in this case, we get a result as false. Now we can straight away compare some numbers, and we can say, is 12 equals 3, and that's false. And if I say not, then that basically will give me the result as true. So these are some simple logical operations which help you when you're working with your data in R. Now we can create a data frame by using an inbuilt data set, empty cars. And let's look at our data frame. So that shows us the values with all the different car models and the different column names. So car models are the row names, and then you have other things like mileage and cylinder and so on, which are the specification for the data. Now what I can do is I can filter out values here using indexing. So I can say data frame. Now in that data frame, I would want to compare the value of mileage, which is greater than or equal to 30, and then I can end it with comma. So that gives me the value wherever the mileage is greater than 30. I can also do a subset on data frame where I can select a particular value. So we can be doing this, or we can be using square brackets. We can also do a dollar and compare the values. Now we will use our logical operations knowledge here. So we will work on data frame where I'm interested in the mileage, which is greater than 20, and I'm looking at the column HP, horsepower, and that should be greater than 100. Remember, when we are doing a AND, both the conditions have to be met as true. And that shows me the result where you're looking at the mileage and you're looking at the horsepower column. Both of these are met, and that's why we get the result. So these are some simple examples of using your logical operations, either when you're working on a data frame. So same thing can be done on a matrix, same thing can be done on a list or a vector or individual values. Now let's also learn about flow control, that is how if else or else if is handled in R. So you can do a single condition check. So for example, I assign a value to hot, which is false, and I'm saying temperature is 50. Now what I would want to check is if the temperature value is greater than 60, which in our case will not be true, because temperature has been assigned 50. So is it greater than 60? No. So if I do this if condition, and I'm saying if the condition is true, then I would want to assign the value of hot to true. And now if you look at the value of hot, it is still false. Why? Because the condition which we passed for our if is not true. It has not been met. So whatever was passed within the statement has not been done. Now let's change the value of temperature as 100. And now if we do the same thing, we say, is my temperature greater than 60, which is right. So then whatever has passed in the bracket will be applied. So hot will be assigned new value. And now if you see, the hot value is set to true. So this is a simple single condition check what you're doing. Now certain times there can be multiple conditions to check, and that's where we use else. So in this case, we go for assigning a value to score, which is 63. So let's do that. And now let's say, is my score value greater than 80, which is not true. So whatever is passed in here, which is print, it's a good score, will not be done, but it will jump to else, and then whatever we have passed in else will be done. So it will say it's not a good score. So let's do this if, and it says it's not a good score. So this is a simple way of using if else, where you are checking two conditions, or you are checking the condition, but what if the condition is not met? Then your control is passed to your next statement. Now I can also do a else if. So I can say score is 63, and I can say, is my score greater than 80? That's my first condition. So it would print good score. But might be I would want to check something else. So I'll say else if, and I'll say, is my score greater than 60? Yeah. And is it less than 80? Remember the and, which has to evaluate and true for both the conditions. So I'll say print decent score. I can still keep on giving conditions here in else if, is score less than 60 and score is greater than 33. That would not meet, so that will be ignored. And then you have else, which says print poor. So first it checks or evaluates for the condition which you have passed for if. If that doesn't work, then it goes to else if, and if anything in else if is met, then it's going to take that into consideration and it will not go for else. If and else if conditions are not met, then it goes to else, and we see decent score already printed here. Now that's a simple example of if, else, and if, else, if, wherein we are evaluating a condition, but probably we have multiple other things to check. Now, how do you work with while loops in R? That's very simple. So what we can do is we can assign a value to x, and now I will say while my x is less than 10. So I'm going to create a loop. So I have said my x has been assigned a value of 0, and that's fine. So this is going to be less than 10. But if we are going to just do this, then it will keep running and it will get into an infinite loop. So we'll see how we do that. So we'll say while x is less than 10, I would want to basically have the value of x. I would want to print x is still less than 10, adding 1 to x. And what we are doing is we are incrementing the value of x. Now, if you do not do this step, then it will get into an infinite loop because x will be always less than 10. So we are incrementing the value of x by 1, and then we are giving a condition. So if at any point of time x is equals to 10, I would want to say x is equal to 10, terminating the loop, and then basically my while loop ends. So we can do this. So let's say x is 0 and then do this while loop, and now you see it is at every step it is basically printing out the value of x. It is still less than 10, adding 1 to x, and it also gives you the value of x. So when we do a x is currently, and I print out the value of x, so it shows me 0. Next time you increment it, it becomes 1 and 2 and so on. So this is where you are using a while loop, where you are looping where based on a particular condition, and then you basically have, once the condition is met, you are able to complete the loop. Now let's look at, let me take this one here. We'll look into functions in a later stage. So let me take this function and let's get rid of this one. I would also want to talk on break statements and while loop. And once we are done with the flow control on while loops, then we can look at the functions aspect. Either we can look at how we control our functions or how we create built-in functions. So let's look at this one and let's continue with our while loop. So we just saw a simple while loop here, and what we also want to see is when you're working with your while loop, how do you break if a particular condition is met. So we saw a simple example of while loop, and that's fine, wherein we were printing out something, we were auto incrementing the value of x, we were also checking at one point of time within our while loop if the value of x was met. We would say we are terminating the loop and it comes out of that. Now, if that does not happen, then we continue doing it. How about a break statement? So break statement is when you would want to end the while loop if a particular condition is met. So for example, here I assign a value to x, which is 0. Now I want to evaluate this lesser than 5. So that means I will be auto incrementing the value of x. So I'll create my while loop. I'll give in a condition that x is less than 5. Now what I want to do is I want to use the cat function, which will print the value. So I'm saying x is currently, and I am printing out the value of x. Then I say print x is less than 5 because we have not yet incremented the value of x. We are adding 1 to x like what we saw in previous example. I am saying x is then incremented by 1. And here I'm saying if x reaches 5. So while we keep incrementing the values within the while loop, we'll see if x's value is 5, we will print it is equal to 5, and we can just do a break. Now, if you do not use a break, you can still end the while loop, but break is basically to end this loop here based on condition which is met, and we can do this and then run this while loop. So you see here x was met as 5 and we just broke out of the loop. So that's your simple while loops, what we are seeing. Similarly, we can work on for loops. So for loops can also be useful. So your conditionals, what we saw as if else or else if, your while loop is while a condition is not yet met, you keep looping and keep doing some actions. Now what you can do is you can also work on for loops. So here I'm creating a vector and then I am going to loop, that is I'm going to iterate through every element. So I'll say for, and when you're using for loops, you'll say for, and then you can give in anything, you can give in any value. I can say I can say x. So I'm just giving temporary variable in vector and then I'm printing it out. So this basically prints all the values one by one. So there is one more way to do it. You can say for and you can say I in, and I would want to take length of the vector. So 1, 2, the length of vector, that is till the last element is reached. I would want to print the vector elements using the value of I. So what is I here? It's the index position, and I can do it in this way. So if you are looping over a list, so I'm creating a list and it's very simple. So you can just do a for loop where you can say for I in list, I want to print the I, and that gives me the list elements. Or you say for I in, and you give from starting position, that is 1, till the length of list, and you would want to print every element. So here we can also use double brackets. So if you would want to loop through a matrix, so sometimes that might be required. So let's create a matrix which has 1 to 25 values around by row, and you look at your matrix, and now what you want to do is you want to iterate through a matrix. So you want to do a looping. So I'll say for I in matrix, I would want to print out the values, and that prints out all the values in matrix. Now what if I want to print the square and square roots of numbers between 1 to 25? So I can say for I, wherein the value starts with 1, ends with 25, and then within my for loop, I can basically give this condition where I'm saying, get me the square root, that is I into I, or get me a square root of I, and just print it out. So I'm saying message I is this one, square root is this, and my square is this, and square root is this. So if I look at this values here, now I am looking at all the values from 1 is to 25. I'm looking at the square of the values, and I'm looking at the square root. So what we did was we did a for. We passed in the elements by saying I in 1 to 25, and within the bracket I have said what do I want to do for every element. So either I've calculated a square, I've calculated a square root, and then I'm printing out when I'm using the message function, which takes the value which you are passing in, comma, the value of I, similarly square, and similarly square root. So these are some simple examples of understanding flow control in R, that is using your for loops, your while loops, and also your if else. Later, we will spend time in learning about functions, which could be either created by the user or built-in functions, and also factors in R. Welcome to this section of R programming, where we will learn about functions, whether that is about inbuilt function or creating your own functions and working on your different data structures. So what are functions? Function is basically a set of statements to perform a specific task. Now, R has a large number of inbuilt functions, or you can say packages, which you can import and start using, or users can create their own functions. So when it comes to functions, the syntax is very simple. You give a function name, you can assign your function to a variable, and a function can take no arguments, one argument, or any number of arguments. So let's see some example on functions. So for example, here we are creating a variable called squares, and we are assigning a function to it. Now this function would take one argument, which is a, and then we use a for loop. So we say for I in from 1 to the number a, we would basically be doing a exponential computation. So what we would do is we would square the value in this particular range and assign that to b and print it. Now when we do this, we can call in this function and pass in a value to look at the square of that particular value. Now this is a simple example of function. So this is how it would look depending on what value you have passed to the function. So for example, we say squares and we pass in a value of 4. So that becomes for I in 1 to 4. So you would start with 1. The value of 1 square would be 1. And then you have your value for 2. So 2 square would be 4. Then we have 3. 3 square would be 9. And then we have 4 square, which is 16. This is a simple example of function. And this is how you can create your own function to calculate or carry out some computations. Now let's look at some other examples before we get into built-in functions, which basically allows you to work with different data structures. So there are different mathematical functions which can be used for your data science or computations. You have your regular expressions which can be used for pattern matching, or you can also use functions for data manipulation. Now, before we get into data manipulation, let's look at how you work with functions, taking some examples. So let me bring up my RStudio, wherein we will try out some examples and see how functions work. Now, here are some examples and we can see how this works. Let me just clean up the console and we can start here. Now here we are creating a simple function which does not take any argument. We call it as hello world, and this will start with the word function and parenthesis. Now that could have arguments passed in. However, this function, we are not passing in any argument. And what we are doing here is we are printing out whatever value is passed within the bracket. So let me just do a control enter. My function is created, and you can straight away call this by just doing this. Now, however, if you would have tried this function without the bracket, for example, something like this, then it would have printed out the complete function. It would have printed out the complete function and whatever you passed in to hello world. But if you would want to call the function, then basically you would just do hello world and then use the brackets. So that's how you call the function, and that's how it shows the result. Now, your function can be with a single argument. So for example, here we are passing in an argument called name, and we can then use this to pass a value to this. So here I'm saying hello name. I have my function, but this one takes a single argument, and we are going to use paste, which basically can concatenate or just adds up whatever you are passing in to paste. So we will say paste hello and then the name. Notice that I have given a space here after hello so that I can have it in the right format, and I can just do this. So the function is created, and now let's pass a name here and just try to call the function. So name is one argument or a single argument which is passed to this function. So let's look at the result, and that shows me the name whichever was passed to this one. Now what we can also have is function created which takes two arguments, and this is a simple example. So here we are creating a function addNum. I'm saying function, it takes two argument. I'm not providing any value or default values for this. We'll see some other examples for those. Now here this particular function takes two arguments, and whatever you pass in here, a addition of that will be seen. So let's create this function and let's call it and test it, and that shows me the result as 70. Now what we can also do is we can add a vector to a number. So vector is list of elements or list of objects, you can say, and here we would want to perform addNum, or we would have to call addNum function by passing in vector, which becomes the first argument and the second value is the next argument. So let's run this one, and that shows me the result wherein 5 as a value has been added to every element of this particular vector. Now when it comes to function, you can also have default argument values which can be passed. So here let's look at as an example. So we have hello name again, but this time instead of passing in just an argument, we will also provide it a value, or you could say that could be considered as a default value. Now when we create this function, we are doing the same thing as previous examples, but we are passing in an argument, and that argument has a value. Now once I do this, I can surely call this function without passing in a value, and that shows me the name which we had assigned to the argument, or we can even pass in a new name which will be assigned to name. So if we do this, it works in both the ways fine. So this is in one way you are passing in a default value, and then basically you can either call the argument or you can assign it a new value. So if we would do something like this, hello name, and then for example I would say name equals say Jerry, and if I would do this, so that also works fine. However, since we are passing in an argument, we are assigning a value, so either we can let it go for the default, or we can just pass in the value, or we can be very specific in mentioning the argument and then the value for it. Now, how do we return value from a function? Let's look at this. So here we are creating a function, we are calling it full name, and this one takes name, wherein we are giving Sachin, and title is say Tendulkar. And what we would do is we would use a return statement here. So return would basically use the paste function. It will take the values of name and title and then glue them together. However, we are using also a space so that there is a space between these two values to the arguments which are passed. Now if I run this this function, my function is created. Now we have already passed named arguments, or we have already passed value to those. So we can straight away say just call the function, and that does whatever you have mentioned in the function body. I could have also said that I could create a new one wherein I will pass new set of values, which we saw in a previous example. And then if we call this, it takes up the new values. So either you can let it go for default, like what we did here. We can also pass in new values, or if you would want to keep it specific, you could basically say full underscore name. That's my function. I could say name equals, and I can say John, and then I will say title Smith, and that's also fine. So we can do this, and that works in the same way as it would have worked with just passing in the names. So this is fine. And if you would want to test it out, say for example, if I would just take off name here and just do this, that also works perfectly fine, wherein we are still using these arguments in the particular order. Now, if I would have changed this one to name, wherein I am already passing in a value for name, and if I tried this, so in this case, what happens is name is Smith, and basically your title becomes John, right? So we have to remember what arguments we are passing, and if we are basically assigning values to the arguments or letting it pick up the default ones. So let's do this, and that looks okay. Now, when you talk about scope of a variable, okay, now before we understand scope of a variable, let me show you some more examples on function. Now, say for example, if you were using built-in functions, we have lots and lots of built-in functions which are available for programmers, which they can use in their data science activities or data processing or computation. Now here we are using a function called rnorm to generate 1,000 random values from a normal distribution of mean 0 and 1. So I would use the rnorm, that's an inbuilt function, and I will call this say normal distribution. So that is already done. Now we can find out the mean on these random values which would have been generated using the inbuilt mean function, and that works perfectly fine. You can also create a histogram out of this, and if I do this, it shows me the histogram. So let's see the histogram here. Let's bring it out, and that shows me the histogram of normal distribution. If you would be interested in knowing about a particular inbuilt function, you can just do a question mark and use the function, and that basically shows you the documentation of the function. So this is a generic function which computes a histogram of a given data value, and here it takes arguments. So this is basically your data. This could be the number of arguments which you are passing in for your histogram to be created. Now we can look at some more examples here. So I can say to histogram with large number of interval breaks, and this is where I'm also specifying breaks and passing in a value. So this allows me to provide arguments to functions by position. Now the same example which we have given here, we can do it without breaks argument, but as a good practice, we should actually give name to the arguments which we are defining. So if I would do this, wherein I'm passing in my data, that is normal distribution, and then for breaks, I'm just giving the value 50, and that is also fine. It works perfectly fine here. Now we can create our own function, which, as we saw in some basic examples, functions which can be without arguments. Say this is a simple example, or with arguments. So this one we have already seen how you can create a function without giving any argument, or by giving an argument and then basically calling in the function. Now when it comes to optional arguments, so we can look at this function wherein I would want to say find out the exponential value of a particular number. So I call it expo value. I use my function. I say this will take the value x. Now that's an argument which we are passing in. We could have given it a value, or we will just let the user provide the value when this function is being called. I will also give a default argument, which is power equals 2. And here we would want to get a histogram of the values with a particular power. So if I create this particular function, that's done. And now I will just pass in my value. I don't need to mention power. That has been given a default value. Yeah, if we would want to change it, then we can pass in that. So let's run this one, and that gives me exponential value, a histogram based on the normal distribution data, and by default it is using power as 2. Now what we could have also done is we could have specifically mentioned a different value for power, and that works perfectly fine. I could have just passed in the value as power, and that also works fine. So here you are using named arguments and basically passing in any other arguments. Now what we can also do is we can use these named arguments, and then we can also do, or we can pass these arguments. That is what we call as passing any other arguments. Now if you look at the explanation of this histogram function, if we look at this, it shows me these 3 dots, and this is what we can use to pass in any other arguments. So let's look at an example for this one. So say for example, I would want to create a function where I am passing named arguments. I am passing in the data, but then I would also want to pass any other arguments which can be passed dynamically. Now for that, we can create a function here wherein I'm calling it expo value again. I'm passing in my x, which will be the data which we'll pass in. You are mentioning power, which is 2, which is a named argument, which can also be considered as a default, or you can change the value, or you can provide a new value. And then I'm also giving these 3 dots, which are also passed in within this particular function. So let me create this function here. Now once that is done, then I can call this function by passing in my data, which is normal distribution, power is 2, and then I'm also using these breaks for getting my histogram with intervals of 50. So let's call this function, and that gives me the histogram. Now what we can also do is sometimes it might be useful to pass logical arguments. So for logical arguments, what we can do is we can create a function which will take the data. Here I'm using a named argument exp, that is for exponential. I'm saying if the value of histogram is false, and then I'm also giving any other arguments. So what we'll do here is in this function, we will say if the value of hist is true, then this block of code will get executed, where you will get a histogram based on the exponential which has been assigned in the function passed as an argument. And if that doesn't hold true, which is by default false as we have given in our function, then this piece of code will get executed. So let's create this function, and that's done. And now we can straight away just pass in our data. Exponential value is given as 2. Histogram has been given in false. That means the else part of the code will get executed. And we can look at the values here. I can also say histogram is true, and that's where we will be calling in the hist function, and I can do this. That shows me the histogram. So in this way we can pass in named arguments, we can pass logicals, and then we can also pass any other arguments for our use case. Now looking further in functions, let's also understand the scope of a variable in a function. So here I am saying v, and then I'm saying I am global variable. Let's create this. And then I'm saying stuff. So I'm global stuff. So this is basically, we have assigned some values to variables v and stuff. Now let's create a function where I'll say fun. I'll use the function and I will say this will take my variable stuff. I'm saying print v. And then for stuff, I'm assigning in a new value, and then I'll print stuff. So let me create this function and let's see how it works. So if, for example, I would just say print v, that shows me the global variable which we had created earlier. And since I'm using that within my function, it basically has the value. Now I also have a global stuff. So I'm saying print stuff, and that shows me whatever was assigned to the variable. And now we will basically call the function by giving in the argument as stuff, the variable which we had created. Now, if we do this, then it says reassigning stuff inside the function. And that's because within the function, we are basically assigning a new value to this stuff. Now, I can also just do a print stuff now. If you see, it still goes back and prints the global variable. So only within the function, reassignment happened. And that's what we understand when we talk about global variable or local variable. Now, to create a function to find the final amount to be paid by a customer after adding 20% tax to the purchased amount, how do we do that? So I'm here creating a function which will take x as 100. And what does that function do? We would want to basically find out the amount which is paid by customer after adding 20% of tax. Now, how do we calculate that? So we take x plus 20% of x, and that would be the final amount which will be paid. So we do a return t, and this is my function. So let's create this function, and then let's pass in a value to see what is the amount which customer would pay with an addition of 20% tax. So this is a simple function where we are passing in one argument, we are giving it a value, and then we are doing computation within the function body. What we can also do is we can create a function where I am passing in an argument, and I can then check the value of that. So if the argument passed was greater than 0, then we would find out the final amount, which is amount plus 20% of the amount. If the amount is less than or equal to amount, then equal to 0, then our final amount is equal to amount, and we return f amount. So here we will be evaluating these conditions, and based on that my function will return the value. So let's create this function and pass in a value, and that shows me 100. So you can just test this by saying amount 1, and say for example I would have passed in 0. Now in this case my final amount is 0 because there is no amount which needs to be paid by the customer. Now checking the argument and the body of a function. So we can always use this inbuilt function args, which will tell me for this particular function what are the arguments and what is the body of the argument, which basically tells me whatever we have coded within the function body. Now to understand the scope, we can create a function here which is taking an argument x, and what does this do? So we assign a value to y, then we basically say g1, and here I am using function of x. Now what does that function of x do? So this one will take the value of y plus multiply x by itself. So this is a function which we are creating, and then I am saying g1 of x. So what you're doing is whatever value was passed in as x, for that function x will be applied. So let's create this function and then pass in a value 10, and that gives me the result as 110. Similarly, we can create another function where we want to do some computation, and then I'm creating one more variable which has basically the function, pass in a value for y, and then basically what you do is you are calling in your g2 function, and then let's call in this function. So let's do this, and let's also create f2, and then finally we will call in f2, which is internally calling g2. So these are some simple examples where you are doing some computations and creating some simple functions. Let's also create a function which is taking two arguments. So here I have g2 function takes two arguments, x and y. What does that function do? Here we are saying y plus x into x, that's my g2. And similarly, I'll create f2, which is going to have a value assigned to y, and this one is going to call in my g2 function, which will take x and y, x which we are passing in here, and y which we have assigned. So let's create this, and then let's call our f2. And what does that f2 do? It basically has the value of y assigned, and then it does whatever is mentioned in g2 with our x and y values. So I'm passing in 10 here. So it is basically y, which is 10, plus you have the x value which has been passed here. So let's look at the calculation, which is 10. So that gives me 110. So 10 into 10 into 10 plus the value of y. So this is how we can create functions which have been assigned some values and then pass in some other values to those. Look at some more examples here when we work with functions, and see how we can use functions to carry out our basic operations or calculations. So for example, here I'm creating a function, and this will take an argument wherein we are saying it would be marks. Now let's do this, and the function body would say result is not defined. Now if the marks are greater than 50, then result will be pass, and you will have the message which is your result is, and then you are passing in the value of result. So let's look at this one. So let's create this function, pretty simple function, and then let's pass in a value here. So I'll say status as 60, which will be checked for the value greater than marks or lesser than marks, and that tells me your result is pass. And if we give this one, then it says your result is not defined. However, we can have additional statements here which can say if the result was lesser than 50, then what should have been printed. This is a simple example. Let's look at one more example, and here my argument is age. Now just notice that we are not passing any default values, or we are not passing any values to the arguments. We are just passing in an argument which will be assigned a value when you call the function. Now here we say age group is not defined, we say vote is not defined, and then we start using some condition checks. So I say if the age passed is greater than 18, then the age group would be adult and the person can vote, and message your age group is and voting status is will be printed out. So we can use this, or from our previous learning we can do a if else and modify the function. So let's create this function and then pass in a simple value to this, and that tells me what is your age group and what is your status to vote. So now if we would want to create a function to convert a name into uppercase, let's see how we can do that. So we are creating a function here which takes the value name. Now then we also find out the length of this particular argument, and for that we are using an inbuilt function called n-character, which will be for your name, and you would want to find out the length of this particular name, and we would say if the length is greater than 5, then we are again using an inbuilt function called toUpper, which will convert the argument or the name passed to uppercase. We will say message user given name is, and then you print out your name. So let's call in this function. So let me first create this, and then I can call in this function, and we clearly see that the number of characters in this word is more than 5, and that's why it is converted to uppercase. However, if you would call the function with a name which has less than 5 characters, it says as it is. Now this is again a simple function which we created. Let's see how you can create a function to calculate bonus. Now here we are passing in 2 arguments. So this function takes 2 arguments. One is salary and one is experience. And then we say if the experience is greater than 5, then bonus percentage will be 10, and else bonus percentage will be 5. And here we will calculate the bonus. So first it will find out how many years of experience a particular employee has, and based on that a value of bonus will be assigned, or bonus percentage will be assigned. And then you say what will be the bonus, that is salary into the bonus percentage, and return the bonus amount. So this is a simple function. Let's basically select this and let's create this function, and then let's calculate the function if the salary is 25,000 and experience is 6 years, and that basically will tell me the value. So let's look at the value. It tells me 2,500, which is 10% of the salary. Similarly, if we go for this one, which will basically go for the execution of else part of the code, we can do this, and that gives me bonuses half of it. Now, how do we handle multiple conditions and multiple actions? So let's look at that. So let's create a function which takes one argument, which is age. We would check if the age is greater than 0. Then we would want a nested if within this condition. So if age is greater than 0, then whatever we have given here will get executed, and this will be this part of your code. And here I'm again checking if age is less than 18, then age group would be kids, else if. Now else if is to check the second condition. So if the age was passed, if it is greater than 0, then we get into this block of the code. Now it was greater than 0, but then is it less than 18? Then I would categorize the person as kids. If age is less than 60, then we will say age group adult, else we will say age group senior. Now we can basically say that we could have given more conditions to this, because here we are saying if age group is less than 18, then the individual would be within the age group of kids. If that is not true, that is it's not less than 18, so probably it is 18 or greater than 18, then we are checking the second condition. If the age is less than 60, age group is adult, and if these two conditions are not met, then it jumps to else, where age group is senior. And if this whole block was ignored because age was less than 0, then we would have just printed out age group is not defined, message is wrong age, and your age is such and such. So this is our whole function. So let's go ahead and run this. Now let's check the age group when the age is 10, when the age is 40, when the age is 65, or when the age is minus 10, which is not defined. Now there are some inbuilt functions which can be used in R, such as your switch function. So looking at this function, that is switch function, we can see, or we can use this for our different kind of operations. So here your switch function returns values match with the first argument, and first argument should be a character. Let's have a look at the example. So say for example you want to return the house rent allowance or HRA amount based on cities. So we create a function called HRA. Now that takes an argument which is city name, and here we will say what does this function do. So here I am saying HRA amount, and I'm going to use the switch function. Now switch function, I'm saying I would want to convert the city name to uppercase so that we can maintain some consistency. And here I'm saying if the city is Bangalore, it would be 7,500. If it is Mumbai, 1,000. If it is Delhi, 8,000. Chennai, 7,500. And you have 5,000 value. And you are returning the HRA amount. Now, what do we do with that? So let's create this function. It's done. And now we will pass in the value. So we will see whatever value has been passed to this, and that gives me the value here, right? So switch is basically taking me directly to this value. Now, however, if I try to provide a city name which is not given in the list, so when I'm saying, say for example, Pune, now what is happening is it is just taking a value which has not been assigned to any of these conditions. If I go for again something else which is in a lower case, now this is where your to upper function will come into use. And if we do this, it basically converts this into uppercase Bangalore, and then basically it gives you the value. So this is the usage of a switch function. Let's look at one more example. So for example, here we are creating a salary range, which will take an argument which will be band, and I will say these are my bands, or you can say these are my options. So I can say L1 is basically 10,000 to 15,000, L2 is so and so, and L3 is so and so, and you return the range. Now let's create this function. Sometimes you have to do it this way. So our function is created, and now we can just do a salary range given a value, and that gives me the range of the values. However, if you pass something which is not mentioned, then it basically prints out null. So in R, you can also use repeat, which can be useful. And what does repeat do? So here I am assigning a value to a variable called time. Let's do that. And then I'm giving a piece of code with repeat. Now what does repeat do? So you're passing in a message which is hello, welcome to our tutorial. And then you're saying if time is greater than or equal to 20, you would want to break out from this loop. And then you also increment the times value. And this will keep repeating till this if condition is met, wherein we have said time value starts from 15. So let's do this. And this basically will print out the message wherein first my time was 15, which was less than 20. So you increment it, it becomes 16, you print it again, 17, print it again, 18, print it again, 19 and 20. And as soon as you reach the times value, which is 20, it breaks out of this and it stops printing this particular message. Okay, now let's look at some more examples. So if you say R, we will use say a function to find the square of any given user number. Okay, if the square value is less than 100, then increment user value by 1 and find square again, and repeat this till square exceeds 100. Pretty simple. So you create a function which takes n as an argument, and you would want to repeat it. So you would want to repeat this by squaring the numbers until the square exceeds 100. And once it reaches 100, you will break out. So this is what we are doing, and we are auto incrementing or incrementing the value of n by 1 every time we calculate a square, and then you return the value of n. So let's create this function, and now let's calculate it for square 6, and that tells me what is the square. Now as soon as your square value touches 100, it basically breaks out of the loop. Now if you would want to find balance in a bank account after n years, if a person has deposited X amount in the beginning and bank gives a interest of 8% per annum, right? This is a simple calculation. So it needs the amount which was deposited, you need the year, and you need the rate. Now year, which is n years, can be given by the user. Rate, we have already given 8%. However, functions main functionality is that you can even assign new values to it. Say later, 1 month down the line, the bank rate changes, might be it increases, might be it decreases, then function should not be modified. It can just take up the new values and start calculating from there on. Now here we will say get the final balance. Function takes amount, the amount which would be deposited, year, and that could be say 4 years or 5 years or 10 years for which you would want to calculate the rate of interest and add it to the amount. So I'll say for I in 1 to year. So that depends on how many times you would want to run this loop. I would say interest would be using the round function. I'm saying amount into rate, whatever is the rate of interest. And then you are giving 2 years. Now final amount will be calculated. So you are basically saying amount plus interest, and you will pass in a message where we'll say year is the value of I, that's first year or second year. Amount, what is the amount, what is the interest you are calculating based on the round function, and final amount will be amount plus the interest. And then you basically say amount will be given or final amount will be assigned to amount. Now if this is a function, you would want to return the final amount. So let's just select this and then basically create a function, and let's say I would want the final balance. If the amount deposited was 5,000, it was kept in the bank for 5 years and rate of interest was 8. Now that should basically give me my final amount. And if we double that, so we say amount is 10,000, number of years is 10, but the rate of interest is less. So let's calculate this, and that gives me the interest. However, if you notice, based on my message, it is basically telling me what was the first amount, what was the interest, what was the final amount. And it does that for all these number of years. So these are some simple examples for your functions, right? Now we can also look at on the similar lines, we can create some interesting functions. So you can find the total number of years required to raise $1,000 if the user deposits $750 per month. So here you're not actually calculating the final amount, but you would want to find out how many years are required to basically have the amount as 8,000. So your function, we are saying the amount is say 550 or say 750 per month. Now I would say let the final amount be 0 as of now, month is 0, and I will say while my final amount is less than or equal to 8,000, I would want to do something, and that is you are incrementing the value of month by 1, because that's your first time your amount is less than 8,000, whatever deposit was made, say $750 per month. And then you have final amount, which is your initial amount, which has been assigned to F amount, that is 0, plus the amount. You print out the message, and then you basically say year is whatever value was passed for month, So you may want to have it for number of years or years with particular amount of month. So we will calculate the year value. Now here what we are doing is we are calling in this required years function without an argument, which takes the default argument, or you can pass it with 750. We can run this. So let's create this function. Pretty simple. Done. And if we do not pass an argument, then the amount is 750, and it tells me what would be or how much time it would take for us to reach from say 750 or 550 to final amount. Similarly, if I would have done this, it tells me again a new value. So we are finding out the total number of years required to raise 1,000 or raise the amount to $1,800. So these are some simple examples of functions which you can use for your operations, your calculations, and also creating functions which can be repeatedly used with either one, either no, or either multiple arguments. Now, so far we were learning on creating our own functions, and we also looked at using some inbuilt functions, either creating a plot or basically doing some basic operations or passing in multiple arguments. So let's look at some more examples. And when we talk about built-in functions, there are lots and lots of built-in functions which are available in R, which can be used. So let's look at these. So for example, here are some built-in functions which can allow you to work with different data structures. For example, you have a sequence function which allows you to create sequences. So for example, I could just say test nums, and I can just say sequence, and here I can say where does it start from. So might be I can say 0 goes all the way to 50, and then I can also say if I would want a jump or how many numbers should be used. So for example, let's do this, and now if I look at test nums, so that shows me the value. However, not to confuse, we could have also done this using assignment operator like this, and then look at your test nums. So it tells me it has created a list of numbers from 0 to 50 which are even numbers. Now you can always do a class of, and let's look at this, and that tells me the objects here are numeric, and say for example I would use type of to see what is this test nums which we just created. There was a typing mistake. Let's check this, and it has the values with double, right? So we have created a sequence here where we are creating a list of numbers which have a space of 2, or you are saying about even numbers. Now you can also use a sort function. So I can do a sorting here, and I can give it in an increasing or a decreasing order. So if for example I have created this sequence, and I could just create a simple variable like this, pass in a vector into this, which could be, say for example, I'll try out test nums, and then look at your v. So those are my numbers, and you can straight away do a sort on your test nums. So I could just do a sort on v, and that basically shows me the number. However, I could also do a sort v, and then I could say here, let's check this v comma, and then you can say decreasing equals true, and let's do this. It just reverse or puts the data in a reverse order, or it sorts based on decreasing value and having the greater value in the beginning and the lowest value at the end. So you can use an inbuilt sort function. Similarly, you can use a reverse. Now reverse need not actually sort the values, it will just reverse the elements in your sequence. For example, let's say v2, and I will again use this one as C, and then just pass your test nums. That's an easier way. Or I could have created a new vector. So I'll say test nums. That's my v2, and you can do a reverse on v2, and that basically shows me the values. But here we see, let's see, so we are looking at, okay, so this was wrong. I should have given a capitals and do it. Yeah, this is fine, and we get the values. However, if I had created something like this, v3, and let's say C, and then let's say 99 and 2 and 3 and 4 and 5 and 78, 100. So that's a vector I'm creating. And now what I can do is I can use the reverse on v3, and you see it has just reversed the elements in the list. Now we could have done this without giving these brackets here, and it shows me the result. So this is good to understand what your sorting does. So sorting is basically going to look at the objects and it's going to sort them in ascending or descending order. Reverse is just going to reverse the elements in your list. Now similarly, you can also use append, which is basically to combine objects. So let's say v4, and that will basically have append, and let's take v2, and let's take v3, and this is what we would want to append. And now look at your value of v4, which basically has everything added into one. So this is your append. Similarly, you have other functions like finding out the absolute value of a number. You would want to find out the square root. You would want to find the sum of all the elements in a vector. You would want to find out the floor value, exponential value of something, and you basically finding out the mean value. So these are some built-in mathematical functions. So you have built-in simple functions, you have mathematical functions, you have regular expressions in R, which can also be used for pattern matching. Now what we can simply do is we can create a variable, let's say text, sorry for caps, let's say text, and here I will pass in something. R is a programming language for data science. Let's do this. And now I would want to use grep function. So I can say grep, and this one needs what I am searching for. So let's say language, and where am I searching for? So I'm searching it in text, and let's do that. And that tells me where is this found. So when I do a grep, I'm trying to find out if this was found in my element. So here I'm saying text and grep language. Similarly, I can also use one more function, which is finding out index positions. So I can also find out index positions by basically giving the vector, and here I can do a grep, pass in my vector a, b, c, d. You are searching for b and in your vector, and that tells you your b is at the index position 2, d is at the index position 4. So here we are using some regular expressions. Now there are also other ways in which R can be used for data manipulation. So let's learn about factors in R, and how do you work with factors and what are they for. So when you talk about factors, so here let's clean this up and let's see what is this. So when you say factors, here we are talking about categorical variables. So categorical variables can take only limited number of different values. Now don't be confused with this histogram example here. Might be we can just look at packages so that that doesn't get confused. So when we talk about categorical variables, we are talking about variables which can belong to only categories. For example, in R, there is a data structure to work with these kind of variables, and that is called your factor. So with factors, we can be sure that all statistical modeling techniques will handle such data correctly. So for example, you can talk about a person's blood group, and you can say the blood group could be A or B or AB or O. So say we collected information about 8 people and we recorded this information as a vector. and we can call it blood group. So let's do that. So let me try that here. So if I say blood group, and then I would like to create a vector here so that we can look at information about 8 people and their blood group, and this can be in the form of a vector which can then be created or converted into factor by using the factor function. So how do we do that? Let's say I have blood group, and here I will basically give in some values. So I will use C function, and here let's give some values. So for example, let's say B, let's say AB, and let's say O, and let's say A again. Let's again say O, might be one more O. Let's say A, and let's say B. So here we have 8 entries, and let's consider we have recorded the blood group of 8 people, and this is in the form of a vector. So for example, let me create this. Now this is a vector which we have created, and you can always look at the value of this one. So let's say blood group, and that basically, okay, there was a spelling mistake. Let's do blood group, and that basically shows me the values. And here you see all the values that are in double quotes. Now we have basically created a vector. Now to convert this vector into factor, we can use the factor function. And how we can do that is basically we can say, for example, let's go here and let's say blood group underscore factor. And for to convert this vector into factor, I will use the factor function and then basically pass my blood group here. And now I have created a factor, and we can look at this factor by just doing an blood group factor. And now if you see, it basically shows us a factor. It does not have any double quotes, and you can also see the factor levels for categorical variables which get printed out here. Now what actually R is doing here is first R scans through vector to see the different categories in there. Then R sorts levels alphabetically, and then it converts the character vector to a vector of integer values. So these integers correspond to set of character values to use when factor is displayed. Now we can always do a structure to find out more details of this. And here I will pass in blood group factor, and let's look at this one. And this one shows me this factor is with 4 levels. So inspecting the structure will reveal that it has 4 levels. It shows me what are the categorical variables, and it shows me some integers. So here we are dealing with a factor of 4 levels. Now A's are recorded, and A would have, say, recorded as 1. So that would be a first level. You have AB's which are recorded here, and that is basically your second level. B is the third level, and O is the fourth level. So when we are looking at this factor, we may think, why this conversion? So categories could be very long character strings, and each time repeating a string or an observation can take up a lot of memory. So using factors and having these levels can reduce the memory space. Now factors are actually integer vectors, and each integer corresponds to a category or a level. Now to specify a different order of levels, we can specify levels inside the factor function. How do we do that? So let's say I will say blood underscore factor 2, and here I will basically give the same. So I'll say factor, and this factor will have blood group which we had created earlier, but this time also I'm going to specify levels and then I can basically pass in a vector here. So within these levels, I will specify the values. What are the levels? So here I will say O, then I'll say A, then let's say B, and then let's say AB. So this is what we are doing here to specify different order of levels, and we are specifying the levels here. Now if I do this, that would have got created, and let's look at blood factor 2, and that shows me the value here below where you have specifically assigned the levels. Now if you look at the previous one where we had blood group factor where levels were automatically understood by R, so we were looking at the categorical variables, we were seeing what are the levels here, and here what we have done is we have just created again a factor, but then we have specified levels in a different order, and you can obviously do a structure on this to compare. So for example, I'll say structure, and then I will say blood factor 2, and that basically shows me the structure with 4 levels. So this was the initial one where we said A, AB, B, and 0, and then there were some integer values which were responding to these categorical variables. Here we have given a different level, and we have a different set of numbers which we see here. So if we compare structure of blood factor and blood factor 2, we will see encoding is different, right? Now that is done. We can also specify the level names. So what we can do is, as we use names function for name of vectors, we can pass vectors to levels here, and there is basically a function what you can use. So let's say I will say levels, and then within this I'll pass blood underscore factor or blood group underscore factor here. So once this is done, let's say blood group. So in this one we created blood group underscore factor, and this one was blood factor 2, so that's okay. I mean, it's just a naming convention. And here let's pass in levels to my blood factor, and then what I can do is I can pass in the values here. So this is when you would want to give specific names, and let's create a vector, and let's call it say BT underscore A, and might be you would want to give BT underscore AB, and then you will give BT underscore B, and the final one is BT underscore O. So what I'm doing is I'm doing the naming for these particular categorical variables by using levels. Now let's do this, and it says blood factor not found. So we have to look which one did we have. So we have blood group factor. So this is what we should have given. So let's say blood group factor, blood group factor. And now we have given some names here. So let's look at the blood group factor now. Blood group underscore factor. And now if you see, we have some levels, or we have given the name to the categorical variable. So if you compare this one, so here we were creating a blood group where we had these variables, and these variables were the categorical variables, which was just creating a vector. Then we created a factor out of it, and then we looked at our factor, we looked at the structure of it, and similarly what we did was we created a different factor. So let me also change the name here, and let me call it blood group factor 2, but here we were specifying levels in a different order. Let's look at this one, so which is blood group factor 2, and then you can look at the structure of this one, blood group factor 2. And here in this example what we did was the initial blood group factor what we had created, we have just given some names to that, like what we would do in case of vector by using the names function. Here you're using the levels function. So we basically created some levels, and let's group at the blood group factor now, which basically has some different names. So what we are doing here is we are just using naming. Now we can also specify the categorical variable names or levels by specifying label arguments. So inside the factor function. So that is basically to give some names or levels. So let's look at this one. And how do we do that? So we can specify by using factor, which basically creates your factor. And then here I'll say blood group. I'm going to specify labels for my naming. So in previous examples, we saw how we were using the levels, right? And this was by specifying levels for a different ordering. And then we could have also done this by saying levels and given some different names, or we can just do labels. And then within this, I will say labels equals, and then I can say C, and then let's give these values, which we have bt underscore a, bt underscore ab, bt underscore b, and o. So let me just copy this one again, and let's put it here. And then we can basically do a control enter. So I would have created a factor here, and then we should remember one thing here, that it is important to follow in the same order as the order of factor levels, that is A, AB, B, or O. Now these are the levels what we are seeing. So if you look at any one of these in the beginning which we had created, it was showing me what levels it has: A, AB, B, and O, and A, AB, B, and O. So we are following the same order, but we are using the labels within my factor creation. Now, sometimes there might be issues because of wrong ordering. So we can actually use a combination of manually specifying the levels and label arguments when creating a factor. Now, what we can do there is we can say factor, and in this case, let's say blood group, which I'm creating. Then I will basically say levels to give the right ordering. And here in levels, let's say O, let's say A, let's say B, and then let's say AB. So this is for my levels which I'm creating. And then what I can also do is I can go for labels. So levels will take care of my ordering, and labels will take care of my naming the categories. So let's say labels, and then we can create a vector and we can give some names. So we can say bt underscore o. What else we have? We have bt underscore a. We can then say bt underscore b, and finally we can say bt underscore ab. And then let's create this one. So now what we have done is we have created a blood group which has levels, which is following your ordering, which is following the naming as we have passed. So if you look at the levels, it tells you the names what you have created. It also tells you all the categorical variables which were used for my blood group, and basically these will have some labels. So we can anytime look at our blood group which we had created in the beginning, and let's look at the values of those. So when we talk about categorical variables, there are two kinds in categorical variables. So you have nominal or you have ordinal. Now in nominal, you don't have any implied order. For example, blood group O is not necessarily greater than A. That is, O is no or not more worth than A that we can think of. Now, trying such comparisons with factors will generate a warning. So, say for example, we would want to look into our blood factor, and let's look at what blood group factor contains. Now that's the new blood group factor. Let's say blood group factor, and here I will try to pull out a value here, and let's compare this with blood factor, and let's look at some other value. Now in this case, we see not meaningful for factors. So it cannot really compare the categorical variables and see if one variable is greater than other or has more worth. Now, there can be many examples where such ordering does exist. And in R, we can impose such ordering in factors, thus making it ordered factor. So inside factor, we can set the argument ordered is true, and we can do that. Now, for example, you would look at the size of a dress. So let's say dress size, and here I will say, for example, let's create a vector, and let's say medium, let's say large, let's say small, let's say again small, and then let's say large, let's say medium, again an entry of large, and then let's say medium. So here I'm creating a vector, and let's see if we missed out any quotes or comma. So it says unexpected symbol, and where is that? So let's look at this one. So we have dress size, and we are looking at C. So I'm saying M, L, S, S, L, and here is a quote missing, and that was the reason. So, and this one also has a quote missing, and now it should resolve. Yeah. So let's look at this one, and now we have created a vector called dress size. Now obviously you can create a factor of this. So I'll say dress size underscore factor, where I would want to look at the ordering of this. So let's create a factor, and in factor we will pass our vector on which we want to convert, or we want to create a factor. We will say ordered equals true. So I am specifying a particular ordering, and then I can also specify levels as we saw earlier. So in levels, we will give the categories. So what categories we have? So we have small, we have medium, and we have large. So these are the three levels which we have. And let's create this as a factor. Now that's done. And what you can do is you can look at the factor, and we can also do a comparison. So let's, for example, look at our factor. What does it contain? It has some levels, and if you closely notice, there are these levels which also have a comparison of which one is worth or more worth than other variable. So you can look at dress size factor, which has some ordering which we have implemented. And now let's do a comparison between dress size and compare it with some other variable and see what is the result. So now it says if it is true or if it is false. Earlier, we were not able to do that because we did not have any ordering. And if we were looking at the variables, we were not really clear if one variable has more worth than others. So these are some simple examples what we have seen. Now we can also look at some more examples. So say, for example, I do a type here. Now that basically is creating a vector. If I would want to compare the element, that is type 3, Is it greater than type 4? It shows me false, right? Now here what we are seeing is that if you are looking at a particular value, okay, we can basically see that there is some comparison happening here. If I compare this with 1 and 2, it tells me true or false. And if I look at this, it also does some comparison. So I can always convert this into factor by using the factor function. So I can do this. If I'm checking, if for example, I would want to create a nominal factor, I can do a type dot factor and it tells me it is true. You can also do a type dot factor 2 and then use the factor function, pass in your type, which is a vector, and here you are saying ordered as true, which we just now saw. And now you look at type dot factor 2, which is creating an ordinal type of variables. Now here we can again create type dot factor 3. So what we are doing here, in this case, we had a vector. We basically said type dot factor. We said factor is of true. And then we looked at the nominal factor. We also did a factor 2. And then we created factor, but we specify ordered as true. So we get ordinal. And now if you look at type dot factor 3, here you are saying ordered and you're also specifying levels like what we did in the previous example. And now you would look at ordered factor with user given order, which also has the levels which clearly show us a comparison between those. Now we can take a different example. We can say type dot factor 4. We are using the factor function. I'm specifying type, which is a vector. I'm saying ordered is t. I'm using level, which is giving me some levels. And then we also have labels, which are basically going to have the naming convention. So let's look at this one and look at type dot factor 4. So it tells me what are the categorical variables, which are small, medium, large, small, large, medium. These are for my type values, which we created a vector here. These are my type values for which we created a vector. We said ordered is true. The levels is small, medium, large, and we gave some names. So we are looking at the values of this. So this basically helps you to work on your categorical variables, wherein you can then compare the values and you can see what does it show. Now here what we are doing is we are creating a different vector. We say small, tall, tallest, medium, small, and so on. Let's look at this one, which is basically type and it has the value. So what we would want to do is we would want to compare height type of first value with the fourth value. So for that, let's create a vector on this type. Ordered is true. Level is we are saying small, medium, tall, and tallest. These are the levels. And now when you look at your type dot factor 5, it basically shows me what are the levels which you have specified. So small is the smallest, then you have medium, which is bigger than small, tall is bigger than medium, tallest is bigger than tall. We have assigned some levels, and based on these levels, now you can compare your values in this factor type dot factor 5. Take the first value, which is small, and compare it with the fourth value, which is medium, and you will know if small is greater than medium, so the result would be false. Now I can also convert this into integer and I can continue working on this. Now here you have basically a sequence. So let's use the sequence function where I'm starting from 0, ending to 20, and there is a jump of 2. So that basically creates a vector. Let's look at the vector value here. And if you would want to sort the vector, so we are using a inbuilt function wherein let's create this vector with these numbers. I can do a sorting. I can also do a sorting with decreasing is true. You can do a reversing of vector. So these are some examples of inbuilt functions which we have already discussed. So here you are doing a reverse, you are finding out the structure, you want to append two vectors, you want to check the class of an object, you want to convert a vector into a list using as.list, converting the vector into a matrix. You are having a sample with two random values between 10 and 20. So these are some inbuilt functions which we have already discussed, such as your absolute, such as your vector and getting an absolute value, or getting a sum of it, or a mean of it, a round, or basically rounding it to two decimal places, getting the ceiling value, getting the floor value, truncating it, returning the log, getting the exponential value, and so on. Now, we have also looked at regular expressions earlier. So regular expressions, let's just revisit that. So here you are basically creating a variable called text, and then you can just do a grep. You can say what you would want to search and where you would want to search it, and that would give you the logical value indicating if the pattern was found. You can try to search something else which might not be found. You can also search for independent values like this, and that basically can give you the position of that particular object within the vector. And here is one more example of working with timestamps. So for example, if I would just do a sys.date, it returns the current system date. If I would want to set that as a variable and then call that variable, it shows me our current time. I can also use as date, and then let's look at this one. So as date, and this would be converted into date. And then you can obviously use formatting techniques like getting the month, getting the day, getting the year. So here we are passing in the date, and then we are saying what format we would be interested in, and that basically gives us the data in a particular format. So that's also useful when you have your time series data, or when you would want to convert the data types and so on. Now there are different ways in which you can do formatting. So for example, in this one we were saying month, day, and year. I can also say for getting the full month name or getting the full year name, I can do this caps. So I can look at this one, and that basically shows me my date in a particular format. So these are some inbuilt functions which we are seeing. And before this, we were seeing factors, which is mainly to work with categorical variables. Either they have levels auto assigned and they might not have labels. So you can give labels, you can give levels, you can control the ordering, you can give levels in a different way so that you can have a different ordering. So this is how you use factors and work on categorical variables, maybe that is nominal or ordinal, and easily you can do your statistical computations on such data. Let's learn about data manipulation in R, and here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function, and this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now, once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now, we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this, and that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use and, or we can use or operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights, and in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2, and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA, and you look at the value. So in this way, I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights overall delay. The computation remains same, but at this time if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this, and that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column, and then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this, and let's look at the value of this one where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping, but earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it where I am saying within this particular data set, I would want to get the sum, or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set, or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column, you can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head, and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights. I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data. So you can do this, which is very useful function, and then you can look at the value of that. Now, what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df. I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on df. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in a random sample. So that's why when you did a view, it shows your 5 values, and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use df, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say b, which is going to get a sample out of a, and I just want 5 random values. So let's look at that. So we have b, which is going to get a set of 5 values from a. Now I will create a result variable which will arrange b, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default descending order. So same thing, we can do it using pipe operator. So piping, so here I will say result. I'm passing in my df, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on one or two or multiple columns. And you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example df, where I have my data. Let's look at this one, and if I just do a df at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name. I can say control shift m, which is for piping. And then basically what you can do is you can do a select, and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder. And here what I'm doing is I'm using a select, where I can look at the new data frame. So let's do this. And I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder, and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4, or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it. So similarly, there is one more package called tidyr, and we'll see how we can use data manipulation done using your tidyr package.
Let's learn about the tidyr package, which makes it easy to tidy your data. And this basically helps you creating a more cleaner data, so which is easy to visualize and model. Now this comes with mainly 4 functions. So you have gather, which makes your data wide, or it makes wide data longer. So that is basically used to stack up multiple columns. You have spread function, which makes long data wider, that is stacking the data together, or stack if you would want to unstack the data to data, and you are talking about data which has same attributes. And then your spread can spread the data across multiple columns. You have separate, which is function which splits single column into multiple columns. And to complement that, you have one more function which is unite, and that combines multiple columns into single columns. So these are four main functions which are used in your tidyr package. So let's look how we work with this. So let me bring up my RStudio here. Now for this, first is, let me just clean up my screen here, doing a Control L. So I will install the package. It is already installed, but we can just do a Control Enter, and then I can say, do you want to restart R prior to reinstall? So install, I'll say okay. And it is basically going to get the package. Now it says package TIDYR, that is tidyrs, has been successfully unpacked. Let's use that package using our library function. And that was built under R version 3.6. Now I can basically start using these functions. So for example, here we are creating a data frame. So let's say n is 10. And then we basically would say, we will call it wide. Now that's the variable name. I'm using the data.frame function. I'm saying ID, which will be 1 to n. So that will take the values from 1 to 10. And then these are the values which have 10 entries. So this is a vector, phase 1, phase 2, phase 3. Let's create a data frame out of it. Now that's done. We can have a look at our data frame by just doing a view wide, and that shows me the ID column, and it has phase.1, phase.2, and phase.3. Now we can use our function. So for example, we can work with gather, that is reshaping the data from wide format to long format. And basically you can say stacking up multiple columns. So let's see how we do that. Here I'll call it long. I'm working on wide. I'm using the piping functionality, and then I'm using gather. So this one, I will say what will be the data which I will use. So we are using wide as a data frame. Then I'm saying response time. So that will be basically one more column. And then you have your columns which you would want to basically stack. So I'm saying from phase 1 to phase 3. So let's do this. And once this is done, let's have a look at our variable long. So this one shows me that I have an ID column, I have the response time column, and I have the phase column, which we mentioned. And that basically has all the values stacked in. So you have phase.1, phase.2, and phase.3. So all the columns are being stacked here. So all my data, so now I have totally 30 entries in this one. So this is basically using your gather function. Now sometimes we may want to use a separate function. Now separate function is basically splitting a single column into multiple columns, so which we would want to use when multiple variables are captured in a single variable column. Okay, so let's look at an example of this one. So let's say long separate, that's what we will call. We will work on this long, which has all the data stacked in as the columns we selected. Then I'm saying separate, I want the phase column, and then I would say when I separate the columns, what are my column names. Now I could also give a separator by giving a comma and then mentioning the separator if that is required. So let's do this. Now once this is done, let's have a look at our long separate. So what we see here is the column which we used. So we were doing a phase column, and that was to be split, and we wanted to split it into target and number. So that's what we see here. So you have phase being split into target and number, and then you have the response time. So this is how you use the separate function. Now there is also something called as unite function, which is basically a complementing of separate function. So it takes multiple columns and combines the elements to a single column. So for example, here we will call it long unite, and we will take long separate, which was separating the data. We want to unite, so we will take phase, target, number, and we want to have a separator between them. So let's basically do this. And now let's look at the result of this unite. So you see, you have the phase and target merged together. So you have phase.1, the separator is dot, as we have mentioned, and we have united multiple columns. So this is one more function of your tidyr, which helps you basically tidy up your data or put it in a particular way. Now, then you have your spread function, and this is basically for unstacking. So that is, if you would want to convert a stack to data, or if you would want to unstack the data which is of same attributes, spread can be used so that you can spread the data across multiple columns. So it will take two columns, say key and value, and spread it into multiple columns. So it makes long data wider. So we can look at this one. We will say long unite. I'm using the piping. I will use the spread function. I'll work on the face column and response time. And let's do this. And then let's do a view on this. So it tells me our data is back in the shape as it was in the beginning. So these are four functions which are very helpful when we work with tidyr package.
So let's learn about visualization. And here we will learn about R, which can be used for your visualization. Now, one thing which we need to understand is because of our ability to see patterns, which is highly developed, we can understand the data better if we can visualize it. So the efficient way or effective way to understand what is in our data or what we have understood in our data, we should or we can use graphical displays, that is your data visualization. So there are actually two types of data visualizations. So you have exploratory data visualization, which helps us to understand the data. And then you have explanatory visualization, which helps us to share our understanding with others. So when you talk about R provides various tools and packages to create data visualizations, and which can be used for both kind of data analysis or both kind of visualizations. So when you talk about exploratory data visualization, the key is to keep all the potentially relevant details together. Now, the objective when we talk about exploratory data analysis is to help you see what is in your data. And the main question is how much details can we interpret? Now, when you talk about different functions which we see here, such as plot, which is more for a generic plotting. You have bar plot, which is used to plot data using rectangular bars, or you can say creating bar charts. You have histogram or hist function to create histograms, where you look at the frequency of the data, or basically used to look at the central tendency of the data. You have box plot, which is used to represent data in the form of quartiles. You have ggplot, which is a package which enables the user to create sophisticated visualizations with the little code using the grammar of graphics. And then you have plotly or plotly. It creates interactive web-based graphs via the open source JavaScript graphing library. Now, before we see some examples here, let's also talk about, when you talk about plotting, let's also try to understand what kind of plots you can have and what kind of techniques you have. So let me open up my RStudio here. Now, for example, I can pull out a particular data set, and let's look at this one. So here I can look at all the panes, and that shows me the information. Now what I can do is I can install and get the inbuilt data sets, and then I can simply do a plot wherein I am doing a plot on chick-weight dataset. So let's see what does that show. It summarizes the relationship between four variables in chick-weight data frame, which is in R's built-in dataset package. Now from these plots, we can see, for example, weight varies systematically over time. You can also see that chicks were assigned to 4 different diets. Now, when we talk about explanatory data analysis or visualization, that shows others what we found in the data. This means we need to make some editorial decisions, what features we would want to highlight for emphasis, what features are distracting or confusing and you want them to be eliminated. right? So there are different ways of doing it. Now, when you talk about your graphics or visualizations, you have, I would say, three different types, or you can say four. So you have the base graphics, which is easiest to learn. Now here we are having an example of base graphics where I can use the base graphics. I can get a data set using library. Then I can simply create using plot function to generate a simple scatter plot of calories with sugar from US serial data frame in the mass package, and then I can give it a title. So this is basically a simple example of base graphics. Now you also have what we call as grid graphics, which is powerful set of modules for building other tools. Now you also have lattice graphics, which is general purpose system based on grid graphics. And then you have your ggplot2, which implements grammar of graphics and is based on grid graphics. So you have different ways. Now here, since I already have used library and I have the data set, I can just do a X. So I can assign the sugar related values to X and calories related value to Y. Then I can use one more, which is library function and calling in grid. Now I can basically use functions such as push viewport if I would want to create a plot using your grid graphics to create the similar kind of plot which we created using base graphics, but this will give you much more power than base graphics. It will have a steep learning curve, but it is usually useful. So I can do this where I'm saying push viewport. Then I can basically say I would want to have a data viewport. I would say different functions of your grid package. So I'm saying rectangle, you have x-axis, y-axis, given some points here. And then basically you can add details to the graph by giving the names to the columns, and you can basically create a simple grid graphics based plot here. Now, there are different other options which we can use to create plots. Now, before we go into understanding how you create plots, let me just give you a brief on what are the different kind of plots and how they can be used. So here we will look at these different plots. Now, for example, we have a bar chart, which is a graph which shows comparisons across discrete categories. So you have x-axis, which will show the categories being compared, and y-axis, which represents a measured value, and height of the bars are proportional to measured values. Now, to create different kind of charts, you can use ggplot, which is a package for creating graphs in R. It is basically a method of thinking about and decomposing complex graphs into logical subunits, and that is a part of tidyverse ecosystem. So it takes each component of graph axes, you can give scales, you can give colors, you can give the objects, and you can build graphs on particular data. You can modify each of those components in a way that's more flexible and user friendly. You can, if you are not providing details for the components, then ggplot will use sensible defaults, and this basically makes it a powerful and a flexible tool. Now here are different options when you use your ggplot, such as you can use geom, or what we call as geometric objects, to form the basis of different type of graphs. For bar charts, you have for line graphs, you have scatter plots, that is underscore point, you have underscore box plot for box plots, you have quartile for continuous x, violin for richer display of distribution, and jitter for small data. So here is some simple example where I would not go into too many details here, but you can just have a look at this one where we are using library function to get the ggplot2 package. Then basically we would want to look into the mileage data. We would want to look at the structure of it. And then we can basically get the tidyverse package. Finally, we can create a bar chart using geom underscore bar. And we can basically also mention what would be in x-axis. Now you can also give different colors to basically add more meaning to your data. You could also go for stacked bar charts. So here we are actually telling ggplot to map the data in the drive column to fill the aesthetic. So here I am giving aesthetic access class, and I'm saying what is the data we need to have, and then we are using geom_bar. So you can also have dodged bar in your ggplot, that is not bar charts which are stacked but next to each other, and you can create that by using your position as position_dodge. Okay, now you can obviously use your different packages which are inbuilt, and you can create your bar charts. And you have other kind of graphs such as line graph, which is basically a type of graph that displays information as a series of data points connected by straight line segments, such as this one. And for this one we are using, if you see, geom_line. Now you can also create a scatter plot, which is a two-dimensional data visualization that uses points to graph the values of two different variables, one on an x-axis, one on y-axis, like what we saw in base graphics example. And they are mainly used if you would want to assess the relationship or lack of relationship between two variables. And you also have histogram, which I mentioned is mainly to look at the distribution of a data, to look at the central tendency of the data, basically looking at your large amount of data or for a single variable. You would be interested in saying where is more data found in terms of frequency, where is lesser data found in the graph, how close the data is towards its midpoint, or what we call as mean, median, mode. So you can use histogram, where you can categorize the data in what we call as bins. So these are some basics on different kind of graphs. Now we can look at some examples and see how that works. So what we were seeing is some quick examples of base graphics or grid graphics. Now here, let's do an example of pie chart for different products and units sold. So you want to create a graph for this. First, let's create a vector and pass in the value here. Now I can also create labels which I would want to assign to these values. And then basically I can plot the chart by saying pie. So that's the kind of chart which I would want to create. And I would say the data would be X and labels. So let's do this, and that shows me a simple pie chart. Now I can also give main details here. So instead of just doing a pie X comma labels, I can say what is the main and then what kind of coloring it should follow. So this is the way you can create a simple plot. Now I can also find out what is the percentage, and then basically I would be interested in plotting the pie chart, which takes X, which takes the labels, which will be the percentage which we are calculating here by doing a round function. And then you can basically give details to your graph. You can say what color it follows. You can basically look at the legend where it needs to be in your chart, what are the values, and then basically fill up the colors. So let's run this one, and that shows me the percentage which was calculated, and it gives me the details, and we can always have a look at our plot. Now if you would want to go for a 3D pie chart, then you can get the package which is Plotrix. Let's use that by calling in the library function. Let's pass in some data to X, and let's give some values or labels which will make more meaning to the data. And then let's plot the 3D graph. So I'm saying pie 3D here, where I'm using X and labels. Then I'm basically doing an explode, which will basically control how your graph looks like and basically give the values. So it also takes the title when you say main and pie chart of countries. Now let's create data for graph. So again, we are having a variable here. We are using the C function, creating a vector, and then let's create a histogram for this one, where I would say xlab, what would be your data around x-axis, what is the color, what is the border, and here I'm creating a simple histogram, which, as I discussed earlier, will always show your values on the x-axis, and y-axis is more of frequency. And then you can look at the set of values and what is their frequency, And we can basically use this histogram for exploratory data analysis, look at the data, try to understand what is the central tendency of your data values. Now we can also give some limits by using the xlim and ylim, and then I can also specify what is the limit. So we have given some values here wherein we have said your x limit is 0 to 40 and y limit is 0 to 5. Now if you compare this with the previous one which we had created, this one based on the frequency had taken the limits, but we can assign limits explicitly by giving this and then create a histogram which makes more meaning. Now let's take another data set, that is air quality. Let's view this to see what does that data contain. So you have ozone, solar, wind, temperature, month, and the day. So this is the kind of information we have in the air quality. Now let's use the plot function to draw a scatter plot, where, as I mentioned, you would be interested in analyzing variables and see what is the relationship between them. So to plot a graph between ozone and wind values, so we will say plot, we will say the data which is air quality. From that I would be interested in the ozone column or ozone field and the wind field. I can create a plot based on this. Now I can also be saying what should be the color, what is the type of the data which you would want to create, and you can look at the information. So you can create a histogram, you can create a scatter plot to basically understand the data better and then infer some information from that data. So let's take the air quality data set itself without specifying any particular column, and you can create a plot which shows me all the different values which you have in the data, and it basically shows you the difference. This is more of an example like what we did for chick weight, where we did a base graphics. Now you can assign labels to the plot. So that is when you are creating a plot, you can say air quality, you will say ozone, and then that's your ozone concentration. You have your YLAB, which is the number of instances. You have what is the title, ozone levels in New York City, what is the color. So these are the details what we have given with our plot function. And let's look at the data. So it just tells me that this is the ozone concentration, the number of instances what you have, and you are looking at the data. Now we could also create a histogram by picking up a particular column, that is such as solar, from your air quality, and that basically shows me the frequency of solar values, and we can then try to find out what is the mid, what is the mean, what is the standard deviation, and so on. You can also look at your histogram and try to understand if it is left skewed and right skewed. So we can do that. Now here, let's get the temperature out from this particular data set. Let's create a histogram on temperature, and that basically shows me the frequency of the temperature values and what values have the most frequency or most occurrence. Now you can create a histogram with labels. So let's do that with the limit, and then let's also use text to basically give in the values, which also takes the values, and for each set of frequency or each set of values it gives me the labels. Now you can have a histogram with non-uniform width, so you could do that by doing a hist function and then passing in your temperature. You can say what will be the main, what is the title, what will be your xlab. It will tell you a limit around x-axis, what is the color, what is the border, what are the breaks you would want to have for your bars, and you can simply create a histogram using this. So this basically takes the breaks which we have given, such as 55 to 60, 60 to 70, 70 to 75, and so on. So this is basically creating a histogram with non-uniform width, and it purely depends on the kind of values what you have. Now you can also create a box plot, which sometimes helps us in understanding the data quartiles, also understanding our outliers. So you can create multiple box plots based on the data from air quality. So we'll select all the data and then we'll do some slicing on the data. So let's create a box plot which tells me the values. And if you look at these points here, like single dots, these are basically your outliers. We can learn about that more in later sections. So you can use your ggplot2 library to analyze a particular data set. So for that, we will first use the install.packages and get ggplot2. So it says, do you want to restart R? And I can say yes. So let it get the package. I think the package was already there. And now let's look at using ggplot2. So for that, I have the library function. And let's do a attach where I'm getting a data set which is empty cars. Now then I will create a variable p1. I will use ggplot. I will pass in my data. I'll give the aesthetics. What is the columns which you would be interested in? And then you are using geom_boxplot to basically create a plot which gives me the box plot for the values here. And this is based on the cylinders which is there in your data. So we can always look at what does our data contain and what kind of values or features are available in the data. Now let's create a box plot. We will also use the coordinate function, and that basically gives me based on the data. So I've changed the coordinates. Now if you look at the previous one where we created a plot, we had mileage on the y-axis and cylinders on the x-axis. Now I did a coordinate flip, and that's like your transpose function. So you have created the box plot, but you have just flipped the coordinates. You can create a box plot and then say fill, which is the factor of cylinder. So that can be used to fill up the values in your box plot. Now what we can also do is we can create factors. So we have learned about factors earlier, which is usually used to work on categorical variables. So here let's create a factor which is empty cars gear. You have AM, you have cylinder, and if you look at the factors which we have created, we have passed our data. What is the field or the column we are interested in? What is the level of values there, and what are the labels for those values, right? So we have learned about factors. You can always look into the previous section and learn more about factors. Now let's create a scatter plot by using the ggplot function. Again, we will use the data as empty cars. I will go for mapping option, and then I will give my aesthetics. That is what would be X, what would be your Y, and you also would want to use what kind of function you are using. So let's go for geom point, and that basically helps me in creating a scatter plot. Now you can create a scatter plot by factors. So here we will say ggplot. So notice in all of these cases, depending on the kind of data you have, depending on the kind of plot you are interested in, you will use the ggplot and then basically a function with that or the inbuilt package. So here I'm saying data is empty cars. I'm going for mapping, which basically will take the values for your X and Y. What is the color? And the coloring will be done based on the factor values. Now, if you remember, factors will obviously have some levels, and those levels will basically help you in differentiating between your categorical variables. So I'm saying as.factor on cylinder, and then I'm using geom point to basically create this scatter plot. So let's do this, and I can look at the values of this one. So it says must be, there is an error which says must at least one color from the hue palette. So let's look at that one. So the error which we were facing when we gave color as the factor values was because when you look at these factors which were created with some labels, if we look at the values of these, it tells me there are NA values in that particular column. Similarly, your gear, or similarly, you can completely look at the complete data set. It tells me cylinder, you have AM, you have gear. Now these have some, we have created some labels, but these have NA values. So what we can do is we can create a scatter plot as we did earlier by giving the aesthetics, and that's a simple scatter plot. wherein I'm also using geom point so that I can have these points by defaults or with defaults. You can also give a color specific, basically if you would want to have different kind of data in the same plot, or I can create scatter plots by different sizes by giving a size, or I can give a color and size, and that's again one way in which you can create your scatter plots. Now let's also see how you can visualize one more data set, which is MPG. So I can also do it in this way, where I set ggplot2 and then pass in, look at the data set what we have here. You can just do a view on this to see what my data contains, if the fields have any NA values, if that's going to affect your plotting. So now what we can do is we can create a bar plot or a bar chart. So I'm saying ggplot, the data would be as we have given in previous lines, that is ggplot2 mpg. Then I will say what should be in my aesthetics and what kind of chart are you going to create. So I'm saying geom underscore bar. So that's my bar chart, and that has basically your class and count. Now you can create a stacked bar chart where your information is stacked in the same bars, and we are still using the same data. We are going for aesthetics, which is class, and then when you say geom bar, which creates your stacked bar, we will use fill, which is drive. And we can always go back and look at our data. For example, you can always look into this. So you have the drive column here, and you are also working on this complete data set. So let's go ahead and create a stacked bar chart. And that basically gives me the information where you have the drive information, which is stacked here. Now you can do a dodge by giving the position as dodge. So we are still going to go for a stack chart, but this time the bars will be next to each other, and that can also be done, which is very useful. You can use this by using geom point, where you are mapping and you are specifying what are your aesthetics. So we were creating a scatter plot. Now you can also use or give more details, where you can say color can be based on the class, and we have different classes, and based on that my points have been colored. Now you can also use a plot ly or plotly library. So let's install this one. I will say yes, for example. Let it basically restart so that all my packages are updated. Then I can access that package using library function, and then create a variable to which you are assigning your plot underscore ly plot. So data is empty cars. What will be your x-axis, what will be your y-axis, and details on your marker, which we have given, wherein I will give a list, which is size, color, which is a combination, and then you have your line, what kind of color it will have, and what will be the width. So this is where I'm going to use plot ly, and let's look at this plot. So it basically gives me some information. Now we see some warnings which are getting generated, but you don't need to worry about that. So you can look at the packages, what you have, and what options you are using. So similarly, we can create one more plot using plot ly and look at the values of those. So that's a plot with a trend which explains me about my data. So this is a simple small tutorial on understanding or how you can have your graphics or visualization used to understand your data. Obviously, there are much more examples, much more ways in which you can pass into your plot functions or your ggplot and the inbuilt packages which are available in R for your visualization. Now that could be for exploratory data analysis or explanatory data analysis. So try these graphs and see if you can change these options and try or create new visualizations.
Now, let's do a hands-on project to perform a time series analysis using R programming. In this project, we'll be using time series energy data to explore the variations in electricity demand and renewable energy supply over time. Over to Ajay now.
Welcome to this session where we will learn on time series analysis using R programming language. So this is basically a mini project where we will look at time series data and how we can analyze it, visualize it to basically find some important information or gather insights from the data. Now, when you talk about time series analysis, time series is basically any data set where your values are measured at different points in time. So when you talk about time series data, data is usually uniformly spaced at a specific frequency. For example, hourly weather measurements, you have daily counts of website visits, monthly sales total, and so on. So when you talk about time series, that can also be irregularly spaced and sporadic. For example, timestamp data in computer systems, event log, or history of 9/11 emergency calls. Now, when we work with time series data, for example, here I'm taking an energy data set, we can see how techniques such as time-based indexing, resampling, rolling windows can help us explore variations in electricity demand and renewable energy supply over time. Now, here we will look at some aspects of this data set which I am considering. So this is Open Power Systems data set, and here is the data set I have. We can look at the data set. Now this is in a simple format. It has time. It basically has values for consumption, and then you have data for wind and solar and wind plus solar. So in certain cases you have only the date and the consumption, but then if we scroll down, we will also find data for wind, solar, wind plus solar, and so on. So this is a time series data set which we would want to work on. Sometimes you may also have the data collected which just does not have the time, but it may also have timestamp. That is, it would have, say, hour, minutes, and seconds, and that can also be worked upon. So let's consider this data set and let's work on this project where we will analyze this time series data set. Now here we can work on this time series data. We can basically create some data structures out of it, such as data frames. We can do some time-based indexing. We can visualize the data. We can look at the seasonality in the data, look at some frequencies, and also do some trend detection. Now, when you talk about this data set, it has electricity production and consumption, which is reported as daily totals in gigawatt hours. And here are the columns of the data, which I was just showing you. So you have data, you have consumption, you have wind, you have solar, and wind plus solar. So this is the data we have, and we will basically explore, say, electricity consumption and production in Germany, which has varied over time. So some of the questions which we can answer here is, when is electricity consumption typically highest and lowest? How do wind and solar power production vary with seasons of the year? What are the long-term trends in electricity consumption, solar power, and wind power? How do wind and solar power production compare with electricity consumption, and how has this ratio changed over time? We can also do wrangling or cleaning of this data or pre-processing of data and create a data frame, and then we can visualize this. Now let's see how do we do that. So I will open up my RStudio and let's look at the data set. So here is the data set. Now I'm picking it up from my machine. You can also pick it up from GitHub. So all the data sets or similar data sets can be found in my GitHub repository. And here I can look in the data sets. You will find a lot of different data sets here. There are some time series data sets such as power. I can search for power, or you have basically coal, or you have this OPSD Germany daily data set, and there are many other data sets which you can work on. Now, to get the documentation on this project, you can also look in my GitHub repository and you can search for repositories, and then basically you can look in data science and R, and here there is a project folder where I've given the documentation, sample data set, and also your time series analysis related document. This is also the code which you can directly import in your RStudio, and you can practice or work on this project. So let's see how does that work. So first thing is we will create a data frame from this data set. Now here, if you see, I am using header as true so that it understands the heading of each column. I'm also giving row.names and I'm specifying date. So there is this date column in the data set as I showed you earlier. Let's look at it again. So you have date, consumption, wind, solar, wind plus solar. So you can suggest that date should become the index column, which can be useful. So you can do this. Now let's just create this. Let's look at what does this data frame contain. And here, if you see, it shows me some data which has been now as a part of this data frame structure. It starts with consumption, wind, solar, wind plus solar. And if you see, this one is becoming my index column. So I can always do a head and look at part of the data frame using head or tail. So look at the first records. So let's see this. Now that shows me the head data. I can also do a tail and look at the ending values. So if you closely see here, we have wind, solar, wind, dot solar, and that basically has NA values. So there are missing values, but let's look at the tail, and that tells me that there is some data available for wind and solar and wind solar. Now we can always look in a tabular format using view, and we can look at the data. So this shows me that there are values in these columns. We see NA values, but if I really scroll down, I can see some values which would be available for wind and solar and wind solar. So I can just use view. Now I can look at the dimensions of this particular object, and that tells me there are 4,384 rows and 4 columns. You can always look at the structure, that is check the data type of each column, which can be very useful. So if I see here, I don't see the date column because date column was considered as an index, which can be useful. But I also look at my other columns, so they are of the num types. So that's the data type for each attribute or each column here. Now we would be interested in looking at this date column. So let's look at the data type of this date column. Now if I try to do this, this will show me that this is null because date as a column does not exist because we created it as an index. So if I look at row names and then I search for my data, show me the index column or row dot names, it tells me these are the values, that's the date column, which we are seeing here. Now we can access a specific row by just doing a my data and give the index value or row name value. So let's look at that, and that shows me based on this index you're looking at the value. You can obviously search for a different date, something like this. You can also pass in a vector and you can give range of values, so that is 0, 1, 2006 to 4 of January, and we can look at this one. So it shows me these are the values. So here actually I'm not giving a range, but I'm just selecting multiple values from row dot names. Now we already know that in R you have a summary function, so you can always do a summary, and that gives you for each column, it gives you minimum, first quartile, median, mean, third quartile, and maximum values. So we are looking at consumption, we are looking at wind, solar, and wind dot solar. Now this is good, but then if I would want to really visualize the data, access the data, do some analysis, then it would be good to take all the columns, and then we can later decide to change the data type of, say, date column if we want to use it. So earlier I was using date as row dot names or the name of the rows or index, what you call in any other programming language. So here I will just use my data set and I'll say header as true. I'm calling it my data 2. Let's look at the data, and this one shows me 5 columns, wherein my first column is the date, consumption, wind, solar, and so on. Now looking at the structure, so let's look at the data type. So it tells me that if now I'm interested in looking at the date column from my data to data frame, it tells me it is a factor with 4384 levels, and these are the values. So it is not in a date time format, it's a factor. Now what we can do is we can convert this into a date format. How do we do that? So let's have a variable x, and I'm going to use as.date function, and I'm going to pass in my date column. So that's assigned to x. Now let's look at the head of x, and it shows me the values. We will also see what kind of class it is, and we will look at the structure of x. So class already says it is date type, and look at the structure, so it shows me the format. Now we have converted this column or column related value into x. Now how do I basically extract values out of it or make it a part of data frame? So first I will use, so all once it has been converted in date format, I will go for as.numeric, and here I will create a variable called year, and I will just do a format on x, which is basically of date type, and then I'm saying %y, so that will get me the year component out of this. Let's look at the values. That shows me year component. Now similarly, we can get the month out of this, and then basically look at the month values. We can get the day out of it, and we can get the day component. Now if I look at my data 2, which we had created earlier, this basically had date, consumption, wind, solar, wind, solar. So what I can do is I can add these extracted columns such as year, month, day to my data frame using a cbind, that is column bind, and I will assign it to my data 2 again. So let's do this. And now if you look at head, it shows me date, so that should be date format, consumption. Now this one might not be date format, but we'll see. You have consumption, wind, solar, and we have extracted the year, month, and day, which can help us for group by. We can do some aggregations, we can do a plotting, and we can do various things by these additional columns. Now let's look at first 3 rows here. So I'll say 1:3 for my data 2, and that shows me some data here. You can always do a head and look at the sample of data. So that basically shows me month, day, your columns, and then you have your date. Now what we can do is we would want to visualize this data. We would want to basically understand the consumption. Now as I said, if we want to visualize the data, say for example I want this, which is consumption of data over years, and this one is in terms of gigawatts per hour, as we were mentioning here, gigawatt hours. So if I would want to create this visual to basically understand the pattern of the data, how do we do it? So we can create a line plot of full time series of Germany's electricity consumption using the plot method. Now how do we do that? So here one of the option is I can straight away use the plot method. I can then say what would be in my x-axis, what would be on my y-axis, what would be the type of graph I would want to plot, what is my name on x-axis, y-axis, and this is the simplest way. So I'm saying my data 2, I'm extracting the year column, and here I'm taking the consumption. So let's create a plot, and here if you see, we are looking at a plot. We do see some tick times, and we see that the data has been divided with every 2 years, so from 2006 onwards to 2016. But then really this data does not give me a very useful way of looking at the data or understanding it. Might be what I can do is I can use the same way, but I can give, apart from x-axis and y-axis, I can say the limits, that is x limit is 2006 to 2018, and y limit is from 800 to 1700. So we can do this, and let's look at this again. This is a plot, but it really does not help me in visualizing and understanding the data. So what are the better options? I can go for multiple plots in a window. As of now, we are just sticking to one plot in window. So If you would want to have multiple plots, you can always change the value here and make it 2 or 3. That will say how many rows and how many columns. So as of now, we will just keep it as it is, par mf row. Now, if I would want to plot, I can straight away give the column name. So I'm interested in getting the consumption. Now I can just do a plot. I'll say my data 2, and I will choose the second column, which is consumption, which we saw here from our data. So consumption was the second column. So I can just do a plot in a straightaway way without mentioning your x-axis, y-axis, limits, and so on. And if you look at this one is giving me a pattern. Now here I am looking at x-axis, y-axis, which is not really named. We do not have a name to this graph, and we are looking at the data. It does show me some kind of pattern, but might be we can make it more meaningful. So I can do it this way, where I say my data second column, let's give axis as year, x-axis, y-axis is consumption. Now that has changed, the x-axis and y-axis. Now I can also give some more details. I can say type should be line. I have the line width. I'm saying color is blue. And let's do this. So this looks more meaningful, might be shows a wavering pattern of consumption over years. I can also give a limit of X, that is 0 to 2018, and that basically shows me the range. Now we can change that and we can be more specific and saying X limit should be 2006 to 2018. And let's look at this. Now this one, once you have given a proper limit, it shows the line graph and it shows what was the consumption in 2006 and over a period till 2018. I can then use any of these options are fine, but it depends on what and whom you are presenting the data or what kind of analysis you're doing. So I can do a plot. I can choose column second, X lab, which is x-axis, y-axis, type is line, width, giving a X limit, Y limit, and then I'm giving a title to this, which is consumption graph. And then basically you're looking at the line graph. Now, those are the options which you can do. Either you could be very specific, or you could just give your column which you want to plot, or obviously make it more meaningful by giving all the details. Now, what we can do is, if we would want to look at this data and understand it better, rather than just looking at a simple line, I can take the log values. So here I'm saying log of my data 2 second column. So I'm taking log values of consumption and I'm taking the difference of logs. So I can say difference, and then you can basically increase or decrease this by multiplying it by some number. So rest remains the same. I'm changing the color, and let's look at this plot. And you see, this basically is giving me a better pattern, which makes meaning. Here we see the log values. So this is, you are using a simple plot function. In R, you can also use ggplot. Now for that, we can install the ggplot package. It's already there in my machine, so I'll say no. I will access this by using the library ggplot2. And now I can use ggplot to plot. So the way you specify here, you can say my data 2, that's the data frame. I'm saying type as O, and when I'm saying line, I am basically going to use x-axis, which is year, y is consumption. And let's look at this plot. So again, we are back to the one which we were doing earlier. Really does not make any sense. It gives us some data, but then really does not give me enough information. I can, in my aesthetics, I can say X as year, Y as consumption. I can do a grouping, and then I can give line and plot. So again, we have some information, but really does not help me, right? Now let's look at other example. So I'm just doing the same thing here, and I'm looking at line type being dashed. I'm using the ggplot's other methods such as geom_line and geom_point to give me more information. And if I look at the plot, it does give me data. It tells me what are the different values. It gives me some kind of pattern, but I would still prefer the way we were doing with plot. Now, We can change the color and obviously add details to it. So what we see is when you use the plot method, which I did earlier, it was choosing pretty good tick locations, that is every 2 years, and labels the years for the x-axis, which was helpful, right? But with these data points, which we were seeing here, or say, for example, this one, or say this one, or say this one, we are looking at some data, but then that really is quite crowded and it is hard to read. You can look at the values, but then it really does not give you enough information. So we can go for plot method, but then we will see how we can consider different data. Now, if I would want to plot the solar and wind time series, so let's see how do we do that. So wind column is what I'm interested in. So first thing is, it was always good to find out the minimum and the maximum values in every column. So I'm saying minimum, I'm saying let's put in here my data 2, and then let's look at the values. So we are looking at the columns. We know consumption is the second column, wind is the third column, and you have solar as the fourth, and this one is the fifth. So let's say, let's find out the minimum of each of these columns which we would want to plot. So let's say minimum of data third column. And here I'm also saying remove the NA values because we do not want to consider the NA values. So let's look at the minimum. That shows me 5.7757. What is the maximum value? It is 826. So that also helps me in giving a limit. If I want to plot wind on y-axis, I can give a y limit from 5 to 850. Consumption wise, let's find out the minimum from second column and maximum. And similarly for solar, find the minimum and maximum, and wind plus solar, minimum and maximum. So this will be helpful when you would want to plot multiple graphs or give some limits. So that's fine. Now for multiple plots, as I said, instead of having one plot, let's plot consumption and wind and solar and try to see a pattern. So I can say par function, and I will say 3 rows and 1 column. So now when I start plotting, you will see you will have multiple plots in one single window. So let's see how we do it. So here, let's look at plot 1. So this one is consumption as we did earlier. And let's look at the data. So that gives me some data. You can always do a zoom and you can look at the data. You can basically expand this graph or you can reduce this graph to see what kind of pattern we have in consumption. Similarly, we can basically choose date being x-axis, my consumption being y-axis, right? So this is being more specific because here we have a range, but it really does not give me enough information. So I will basically give x-axis, y-axis, I will give the name, that is daily totals, and then I will basically give consumption, color, and y limit based on my minimum and maximum limits. So let's do this. And now we can look at the data here. So let's see, this data makes a little more meaning because we are looking at the dates. And let me do a zoom. So it shows me all the dates. It shows me the data points. It shows me how the data pattern is changing for consumption. Now, this is for consumption. So what we can do is we can also extract specific data. So if you see here, I have done some testing where I'm saying, okay, I would want to get a date specifically. I would want to extract some value. So we are looking at the date column, but if you remember, we did not change the data type. We just changed the data type of date column. We extracted year, month out of it. It would be good if we can convert a column into date time format and put that in our data frame. Now, let's look at the plot 2. This is mainly for your column, which should be consumption and wind and solar. So here I see it is solar data, and I can plot this one to see how it looks like. And that tells me from 2006 onwards, we have some pattern. I can be more specific where I say I would be giving date and then the column for solar, x-axis, y-axis, what is the type, what is the y limit, and what is the color. It is always good to specify your x and y axis, give a name rather than let it automatically pick up. Now this makes more meaning because it shows me some dates. Similarly, we can do for wind. So either you do it just by giving the column or you give your x and y axis. So let's look at this one. And this shows me the data. So we can choose plot 3. This one we can choose plot 2. We can choose plot 1, and we can put all that data in one graph. So that's when you are putting in multi plots in one particular graph. You can always do a zoom. You can always look at the data, right? And this is usually useful to look at the pattern, what kind of pattern we see, what data we have, and so on. Now, moving forward, so we have seen how you are creating these plots all in one window. Let me reset this back to one plot per window, and let's basically plot time series in a single year. So what we have seen is that when you look at the plot method, it was quite crowded. Then we looked at solar and wind. And if you compare that, you will see your consumption pattern, your solar pattern, your wind pattern, and basically we can see from this particular data some kind of pattern. So electricity consumption is highest in the winter, where we will see what is the consumption. Is it highest in winter or is it in summer? We can see that by breaking a year further into months, we can see that. But we see a pattern which goes for every year or every 2 years being highest at a particular point of time, and then it drops down. So electricity consumption is highest in winter, and that might be due to electrical heating and increased lighting usage, and lowest in summer. Now, when you look at electricity consumption, appears to split into two clusters. We can always look at the consumption, one with oscillation centered roundly around 1400 gigawatts. So you can always look at 1400 gigawatts and you see all the values here which are in that particular consumption. Another with fewer and more scattered data points, centrally roughed around 1150. So if you really expand this, you can see you will have a lot of data points at this point. Now, we might guess that these clusters correspond with weekdays and weekends, which we can see if you break that data into yearly, monthly, weekly, and so on. Now, if you look at solar production, that is highest in summer when sunlight is most abundant, and lowest in winter. So obviously when you're making or gathering some insights, when you're looking at the data, you are also using your domain knowledge, your business knowledge, your knowledge of business to understand how this goes. If you look at wind power production, that's again highest in winters and drops down in summer. So due to stronger winds and more frequent storms, and lowest in summer. So there is some kind of increasing trend in wind power production over years, which we can see here over the years. And all the time series data what we are looking at is referring or showing us some kind of seasonality. That is, we are looking at seasonality in which a pattern is repeating again and again at regular times, at regular intervals. So if you look at consumption, solar, and wind time series, that oscillates between high and low values on a yearly time scale, which we can break down and see. I'll show you that. It corresponds with the seasonal changes in weather over the year. So seasonality does not have to correspond with meteorological reasons. For example, if you look at retail sales data, that will show you yearly seasonality with increased sales in particular months. So seasonality, when we say, can occur on other time scales. So the plots what we are seeing here, they are fine, but if you look at those plots, they might show some kind of weekly seasonality also. So in your consumption corresponding to weekdays and weekends. So let's plot for one single year. Now, how do I do that? So first is I will look at my data 2. That shows me the structure. It shows me date, which is factor, other columns, which are all numerics. Now, like we did earlier, I'll repeat this step where I'm going to convert the date column into date type, look at head of it, look at class of it, look at the structure of it, right? And then what I want to do is I want to add this to my data frame. So I will create a variable called mod data, and this one will have as data, and I'm formatting the value of X, which is date time, into month, day, and year. So let's do that. And now you look at the mod data, which I created, like modified data. So this is the format I have. It is in date type, if you carefully see here. And then I can look at the head of it. So it says me mod data. Now what we did here is when I said my data 3. So my data 3, we did a cbind and I did a mod data, which is going to add this column to my other columns of my data 2. So my new data frame is my data 3. Let's look at the structure of it, and you see there is this date column. I can delete it, I can remove it, I can let it be, right? So that depends on our choice. Might be we want to, once our analysis is done, we want to remove the mod data, right? So we can keep both of them. Now let's basically extract data for a particular year. Now how do you do that? So this is some wrangling. So I will say my data 4, let's call it my data 4, and I will use subset function. So subset will work on my data 3, that's the data. And what I'll do is I will do a subset. How is the subset found? So I'll say take the mod data column, the value should be greater than or equal to 2017 and should be less than 2017 December 31st. So I'm getting data for 1 year and I'm storing it as my data 4. Let's get the head of it, and you see we are specifically looking at 2017 related data. Now let's do a plotting of this where I will only create a plot for 1 year. So I'm saying my data 4, that's my new data what we got. So here I am going to take the first column, which is mod data. I'm going to take the third column, which is consumption. So I'm looking at the date format for 1 year, consumption values for it, and then rest of the things as we have done earlier. Let's look at the plot, and this makes more meaning, right? So when you look at this plot, it tells me Jan to Jan. It shows me some kind of pattern where I have divided the year into months, right? And it is broken down into say 2 months, so Jan and March and May and July and so on, but we still see a pattern, and that gives me good understanding of pattern where I've broken it down into months. So this is where you have taken time series in a single year to investigate further, and this is what we see, right? Now we can clearly see there are some weekly oscillations. One more interesting feature is that at this level of granularity, that is when you're looking at yearly data, there is a drastic decrease in electricity consumption in early January and late December during the holidays, or probably we can assume that this is holidays. Now I can zoom in further and look at just Jan and Feb data. Let's see how we do that, and let's see how we work by zooming in the data further. So to zoom in the data further, let's see how we do it. Now here we have this my data 4, which is basically having a subset, right? So let's work on this one. So I will say my data 4, which earlier I was taking data 3, I was doing a subset and I was giving the date, but this time I will make it more narrower. So I'll say my data 4, I will say subset from my data 3, and I will choose mod data column, which we have modified with the date format. I will choose the starting date as 1701, that is Jan, and then let's go till Feb and let's create this. Now let's look at the head of this. So it shows me we have the data which is Jan, and then you can basically look at more on this. Now Again, as I said earlier, let's find out the minimum of this from the first column. So that is basically your mod data. So let's look into this one, and that basically will give me minimum and maximum. Let's look at the values. So this one tells me Jan 17, January 1, and maximum is your Feb 28th, second month 2017. So we are actually looking at 2 months data here. Let's look at the Y minimum. So this is, I will look at column 3. Now what is column 3? Consumption. So let's look at the minimum value for consumption, maximum value of consumption. Let's look at the values which can be given as our limits. Now this is the minimum and maximum. Now let's do a plotting for this data which has been narrowed down for consumption based on my data. So I'm saying my first column, which is mod data, and then third column, which is consumption. I'm giving some naming convention for, namings for your x-axis, y-axis, what is my consumption, or what is my title here, what is the color, and then you see I'm using X limit to give the minimum and maximum limit and Y limit. So let's look at this data. And if you look at this data, it is specifically for 2 months. And again, I can look at the pattern here. What I can also do is I can add some grid here. So I can basically look at this data and make more meaning out of it. So it is bi-weekly data, you can see. Now I can add a line here using ab line, and then I can basically choose what lines I would want to add horizontally. So that basically allows me to dissect the data and look at data in a more meaningful way. I can also add vertical lines. So vertical lines is, I'm saying sequence will be minimum, maximum, and I'm saying an interval of 7. So let's do this. And this basically has added some lines every week. And you can see at the end of week, it is dropping, and then it is starting again. It peaks somewhere in the mid of the week, and again, it drops down. So this is, you're looking at your consumption data, right? Now what we can also do is we can create some box plots. So when we looked at zooming in data for Jan and Feb, you can add some data points like this. So consumption is highest on the weekdays, as I showed you here, and lowest on the weekends. So this is what we are seeing when we are breaking the data or zooming it further for a couple of months. So we have vertical grid lines, and we have nicely formatted tick labels, that is Jan 1st, Jan 15th, Feb 1st, and so on. So we can easily tell which days are weekdays and weekends with use of these grid lines and basically breaking it down. So there are many other ways to actually visualize your time series data depending on what patterns you're trying to explore. You can use scatter plots, you can use heat maps, you can use histograms, and so on. Now, moving further, we would want to explore the seasonality, right? So when you further explore the seasonality of our data, we can use box plots basically to group the data by different time periods and display the distribution for each group. Now, how do we do that? Let's come here and let's see how box plot works. So I can just do a simple box plot, and I can choose my consumption column, and that gives me just the consumption data, but this really does not give me any meaning. I can look at solar data, I can look at the wind data, and we can also see some outliers here. So we can create box plots, but if we would want to do a box plot, what is box plot? It is basically a visual display of your 5-number summary. That is, you want to look at your mean, median, you want to look at your 25th percentile, 50 percentile, or 75th percentile. So we can use a quantile function, use the consumption column, and then you basically give a vector which shows you 5-number summary. So that's your quantile. And then let's do a box plot. So if you are looking at quantile, it tells me what is the minimum, what is 25th percentile, 50, 75th, and 100. That's from my consumption column. So let's create a box plot for consumption. Let's give it a name as consumption. Let's give y-axis as consumption and a limit for y-axis. Now that's my consumption graph. So I can look at yearly data. Now that will make more meaning rather than just looking at the complete consumption data. So how do we do it yearly? So we will say consumption, and then I will say the year column. So it is consumption, but grouped based on year. So here I can give x-axis, y-axis, and I can give y limit. So let's create this, and this makes more meaning. We can give some coloring scheme here, but now I'm looking at 2006, 2007, 8, 9, and so on. And we can look at the data. What is the range, right? It gives me 5 percentile, or sorry, 5 number summary of the data per year, and it basically allows me to look at the seasonality of this. Similarly, we can create box plot by just giving consumption, yearly grouped, and here I'm giving the title as consumption, y-axis, x-axis, and y limit, wherein I can also use LAS. So this is one more feature which you can do, and that basically will give me the tick points. If you compare this one to the previous graph, so when I created this previous graph, I had 2006, 2008, and I had from 600 to 1800. And if I go for the next one, I am basically seeing more useful information. Now let's look at monthly data. So I would want to group it based on months, and let's create that. So this gives me the monthly data where I'm looking at months, and I could select a particular year, or I can just do a grouping based on months. So I can have multiple plots to see a difference here. So let's do this. Now let's create a box plot for consumption, which is monthly data, and let's give it a color. Let's look at the wind data, which is again grouped monthly, and let's look at the solar data, which is grouped monthly. Now if I zoom in, it basically gives me the seasonality of the data for your wind, for your consumption, for your solar. So what we are doing is we are creating these box plots which are giving us values. Now what I can also do is I could look at the day wise also. But before we look into this, how do I infer some information from these box plots which are being created? So this is what we have done, where we are looking at the data for month, and these box plots give me year seasonality, which we were seeing in earlier plots, but give some additional insights. So if I look at the data here, it tells me the electricity consumption is generally higher in winter. Now this is based on months, so we can see consumption is higher in winters and lower in summer. So we can obviously look at our plot, we can see where it is lower, where it is higher, and then we can look at the median and lower two quartiles are lower in December and January compared to November and February. So that is, you look at the quartiles and you will see that the median and lower two quartiles are lower in December and January. Here Jan and December, so you can look at from my plot. Now this is giving you some idea on seasonality. Now that might be due to business being closed over holidays. Now this one we were also seeing when we looked at time series for 2017 only, and box plot basically confirms that there is this consistent pattern throughout the years. Now when you look at your solar and wind power production, both will give you a year seasonality, what we are seeing here. And if basically I look at the data, so it depends on what parameters you are choosing, but if you look at solar, it will reflect the effect of occasional extreme wind speeds associated with storms and other transient. And since we are grouping it based on months, we can see this pattern is quite evident every year. Now, what we can do is we can group the data day wise. So here, let me again reset this to one plot per graph. Now I'll say box plot. I'll say consumption, which is grouped based on day. Now we know that there is a day column, and let's give a y limit and let's look at the data. So this is where I'm grouping the data day wise. So you look at 31 days and you look at the box plot. So this is where you are plotting it on a daily basis. So you can look at the data, you can break it down to a particular week. So here I have given a day and I have chosen all the 31 days, but I can break it down to a week and I can look at the data. So if we look at the data per week or per day, we can basically infer that electricity consumption, where I'm doing a consumption group by day, is higher on weekdays than on weekends. So time series with strong seasonality can often be represented with models that can decompose signal into seasonality and long trend. Now this is an easy way. Now how do we look at the frequency of the data? That could be interesting to see. So let me look at, say, the yearly data which we were seeing here. Now let's go further, and here we have looked at data. So what we will do is we look at the frequency. Now when you look at the frequency, when you talk about frequency in your data, so we have the modified date column which gives me a frequency, and if we really look into the data, that will tell me that the data is on a daily basis. So for that, let's look at my data 3 again, which gives me data, and you can just see all the data or dates are in sequence. So your 22, 23, 24, 25, 26, and so on. I can access a dplyr package that is basically allowing me to work in a better way. Now I can look at the summary of this, and for all my columns, I'm seeing what is the minimum 5-number summary, date, and consumption. So date does not show me anything because this is not in a date format, it is just a factor, but other things have the 5-number summary. So we are looking at wind plus solar, we are looking at year and month and day and all these columns. Now what we will do is we will want to find out the sum of each column, how many entries does it have, and we will say the value should, NA value should not be considered. So let's look at this one. So it tells me for my particular columns. So let me run this again, and that shows me for each column how many values you have, and these counts do not include the NA values. Now similarly, I can find out specifically for consumption. I can find out, is there any NA value? So I'm saying is.NA, and let's find out if there is any NA value or missing value in consumption. It says 0. Okay, that's good. If you look in wind, it tells me there are 1463 entries which are NA. Similarly solar, similarly wind dot solar or wind plus solar. So it gives me a count of NA values, that is missing values, and also values which are not missing. So to understand frequency, what we can do is we can find out the minimum on the date, that is the first column, and I'm saying RM NA.RM is true, that is get rid of NA values and find out the minimum. And let's look at the minimum value. This is the minimum from my modified date. Now if I would want to get the frequency, I can basically use sequence function. So I can say from X minimum, that is the minimum value, I want to look at the frequency, that is day wise, and let's just look at 5 entries and see if there is a day by day frequency. So let's look at the value of this, and obviously it tells me there is day wise frequency. So that allows me to look at the frequency, look at the type of it. It is an integer, class is a date. So similarly, we can say from X minimum, we can basically look at the frequency month wise, and I can again look at 5 records. So that shows me monthly data, right? So I can extract the data for frequency, similarly yearly data, and that's also very useful. Now we can select data which has NA values for wind. So how do I do it? I would want to find out the wind column, and I want to find out where the values are NA. So I will create a variable, and here I will say my data 3, and then I give a conditional where I say is NA in the column. So let's do this. Now once I've done this, I have said that my selected wind data from my data 3 where we said NA values, and I will give the names to this. So names should be in my data 3. I'm interested in mod data, consumption, wind, and solar. So these are the 4 columns I'm interested in. Let's look at first 10 records here, or first 10 rows. So that tells me these are the values where wind has NA or missing values. I can always do a view, and that gives me the complete data. So it basically shows me 1463 entries, and here it shows me all NA values. So you can look at all the way to the end, and it shows me wind has NA. Solar does have some value here in the last row, but then also if you see, the numbers have a difference. So you have 1461 and then you have 2174. So there is a difference. So there is some data in between where wind has some values. So we have found out NA values. Now what we will do is we will select data which does not have NA values. So I will call it cell selected wind 2. I'll again use my data 3. I will say which, but now I'm saying not NA from this column, and I will select the data for the columns. So I'm interested in looking at 10 records, and this shows me not NA values, so no more missing values. So if I really look at this data as I saw earlier, which has NA, and if I look at these values which are not NA for the wind column, so looking at these two results, we will know that in year 2011 wind column has some missing values. So let's focus on year 2011. So how do I do that? Let's call it a different variable. I'll say my data 3. I will say here, when I say which, where we were saying NA, here I will say the year should have a value of 2011, and I want all these columns. Let's look at the data here, and this is showing me 2011, but we are not seeing all the values. So there are some values, but then there are some missing values also for 2011 based on whatever analysis we have done. So let's look at the class of this. It is basically a data frame, do a view, and this one will help me in finding out where are the NA values. So if you just scroll down, looking at all the data, let's search if wind column has a NA or a missing value, and I will see if there is any missing value, in which column or which row it is for the wind column. So we have all the values which are existing. I could select and search for one specific value, and I'll show you how we can do that. So here, let's scroll all the way down. So it's like you're exploring your data and seeing is wind column having NA or missing value for a particular row. And let's scroll here, and here you see there is a missing value for one particular row. So 13th December 2011 has wind value, 15th December has wind value, but your 14th December does not have, right? Similarly, we can search. So there was only one entry which was missing. Now that could be for some reason, might be it was not calculated, might be it was not tabulated. So we have a missing value, and that can affect my plotting, that can affect my analysis. So let's look at the number of rows in this, which will tell me how many rows we have for 2011. So it tells me 365. So that is basically the number of days in a year. Now we will find out if there were NA values. So we earlier checked total number of NA values per column. That is in your row number 265 to 269. We can see here 265 to 269. So this is where we were seeing, are there any NA values, right? So let's go back here, and we want to find out the number of NA values for a particular year. How do I do it? So I can just do a sum. I will say is NA. Now I'm interested in my data 3 wind column, and I'm saying my year has to be 2011, but I'm finding out the NA values. So let's do this, and it tells me 1, and that's right. That's what we saw when we did a view. Let's see how many non-NA values you have, and that is 364. So that basically satisfies my logic. So it's 364 plus 1 missing, so there are 365. Let's look at the structure of this. It tells me you have modified date and date format, you have consumption, wind, and solar. Now let's create a variable, selected wind 4. I will say wind 3, that is, which was having all my NA and non-NA values for 2011. I will say let's find out the NA value, because I'm interested in finding out that particular row. So I'm saying find out where the value is NA, and I want all the columns. Let's look at this one, and this is my specific row which has a NA value. Now we know that data follows a day-wise frequency, which we have clearly seen. Now let's select data which has NA and non-NA values. So let's call it test 1. I will use wind 3, which has NA and non-NA values. But now I will say I want the modified date, which should be greater than 12/12/2001. Now remember, we had, when we were doing a view, we saw that one particular day, or what we see here, 14th of December, there is no date. So I will select a subset of data which includes this NA and non-NA. That is, might be I can take 13th of December and 15th of December. So let's start from 12/12. So the date should be greater than 12/12. That means 13th, and it should be less than 16. So that is 15th, and the columns, right? So now we have some data. Let's look at this. So I've selected a subset of data. I could have done this using subset also. So I have NA and non-NA values. Now, why are we doing this? So sometimes you might have some data for a particular column, and you may want to find out if there are any missing values. Might be you want to fill them up or replace them with something. So that is usually useful when you are doing a trend detection. So say, for example, you have data for every month, and might be in one of the months you have missed, or might be you have data for every year collected monthly, and then in one of the years for a couple of months you don't have the data. Like I can say 2016, I have data for all 12 months, 2017, all 12 months, 2018, might be I don't have data for March and June, 2019, I don't have data for same months. So I can forward fill or backward fill them using the previous year's same month data. So we can do that. So here I have test data where I've extracted a subset of data. I can look at the class of this. It is a data frame. Structure of this, it has the columns. Now let's use the library and function and use the tidyr package. And what we will do is we will fill it up. So I will use test 1. I will fill the wind column which has a missing value. Now once you do this, if you notice, it has done a forward fill. So it has taken the previous value and it has just filled up that. So you can fill up the data using different directions, such as up and down, left and right, and so on. So we can take care of missing values in our frequency data, which allows us to basically analyze the data in a better way. Now here we will want to also look at some more data. So this is to deal with frequencies of fill column, wherein you can take care of missing values forward filled. So filling values can be done in different directions, as I said, and you may want to first convert your time series to specified frequency if your data does not have a frequency, but we had. Now, if you do not have a frequency, might be you can convert it into a frequency such as weekly, daily, monthly, as I showed you, and then basically you can do a forward fill for the values. So for example, if I have my data, I can break it down into weekly and then look at the values, and if there are any values missing for weekly data, I can use a forward fill. So that can take care of my frequency data. Then let's look at the trends of the data, which is the last part of this project. So basically, let's look at the trend. So when you say trend, what does that mean? So in time series data, you always have some kind of trend. So that will exhibit some slow, gradual variability in addition to higher frequency variability, such as seasonality and noise. Now, to visualize these trends, what we do is we use what we call as rolling means. So we know how our data is spread over year or month or day. But how about looking at a rolling average and see what is the difference? So a rolling mean will tend to smooth a time series by averaging out the variations and frequencies. So this can be higher than the window size. So there is something called as windowing, where you can choose a set of time frame. You can also average out any seasonality on a time scale equal to window size. So this will allow you to look at lower frequency variation in the data. So when we are looking at electricity consumption time series, we already saw there is a weekly pattern, there is a yearly seasonality, which we saw using box plots. So we can also look at the rolling means of the time scales. How do we do that? So for this, you can use some package like Zoo, and then you can basically use a rolling mean using the Zoo package, and you can say what is the frequency with which you want to calculate the rolling mean. Now, how do we do this? Let's look at this data. So here I'm going to look at my data 3, which we have been using so far. Now let's call it a 3-day test. You can give it any name. I'm going to use my data 3. I'm using the pipe in function. Now I will use dplyr and I will arrange the data descending in year. Now you can always break it down step by step and you can see the result of this. So I'm going to arrange this data in descending order of year. So obviously my last one, 2017 or 2018, will be on the top. You want to group the data by year. So it depends on how many years we have, we'll see. So you can group the data by year. Now this data is then used to basically mutate. So mutate function is going to allow me to use this rolling mean. So I'll call it as says 03 day. So I'm going to calculate a rolling mean every 3 days for my consumption column. And basically let's ungroup this. So let's see how this works. Sorry. Yeah, let's look at this. And here, when I'm doing a 3-day test, let's look at the result of this and then I'll explain this. So if you see here, we have the test 3-day column. Now this has the rolling average. Now what does that mean? So first value here, what we see is 1367 is the average consumption in 2017 from the first date with a data point on either side of it. That is, you can look at this date, so 1130, then you look at you are looking at the value 1367 here. So you look at 1130, 1441, 1530. If I take a mean of these, so for example, if I would just do this part, and that is giving me mean, okay, because I have a comment. So let's basically add anything as comment, and then let's do this. So it says me 1367. That's what we are seeing here, right? So you're getting a rolling average every 3 days. Similarly, if you want every 5 days, it takes the 5 values and it gets the mid value, right? So you can always find out the mean, rolling mean for a particular frequency. Now, let's do that for 7 days, that is weekly data, and yearly data, that is 365 days. So how do I do it? Same logic, my data test. Now I'm using my data 3. I'm arranging it in a descending order. I'm grouping by year. So when you do a group by year, so earlier when we did a grouping by and when we looked at the data, it was telling me how many rows we had, right? So let's do a grouping by year and let's say test 07. So that's a rolling average every 7 days. And I'm also saying take care of the NA values. Similarly, I'm getting rolling average every 365 days. Might be you can do quarterly, might be you can do half yearly. And let's do this. So let's create this, my data test. And let's look at the result of this. So I will use my data test. I will say arrange based on modified date. Now we know there is a column called modified date. I want to just look at 2017 data. So I'm doing a filter, right? And then I will choose what are the columns I'm interested in. So I will look at the 7 and 365 day. And let's look at, say, first 7 records. So let's do this. And that basically gives me the consumption value, modified date, year, and my rolling 7-day average or the 7-day mean, which is for first 7 days. And then 365, you will not see the data here, but if I do a view on this, I can basically see the values. So you can always select a particular column to see the values. These are the values for every 7-day rolling average. This is for 365 days, every 365 days. So you see all the values are missing, but every 365 entry, you will have basically some data. Now, let's do a plotting of this and basically visualize this data which we are seeing rolling average. So let me first do a plotting, one plot per graph. And let's do a plotting. I will take consumption data, x-axis, y-axis, color, and give a title to this. So let's create this, and that's my consumption data, which is spread over a period of time, and that's fair enough. But now let's add some more plot to this. So I will add the 7-day rolling average to this. So for second plot to be added in the same one, in R you can use points. So I will say points. I will choose 7 data column. Type is line, width, X limit, Y limit, and color. So let's do this. And that's my pattern 7-day rolling average, which basically gives me some kind of trend. Similarly, I can add one more here, and this time I will choose the 365 day and look at the pattern lines. So now you see some dots here. Well, you could do it in a different way. So I can just add legend to this, and I can say legend will be where in x-axis and y-axis. So I'm saying it will be 2500 and y is 1800. So my legend will come in somewhere here. I'm saying my legend will have consumption, test, and this one I can give some names. I can give what is the color. I can say what kind of legend. It explains what is for each color, and then basically a vector. So let's add a legend to this, and I've added a legend. Now you can do a zoom and look at the data, and here I see that my x-axis is fine, but y-axis is going a little out of my plotting area. So I can actually change that. So here I have 1800. How about making it 1600? And let's look at this one. So we can basically go for this one and start again here, plot and points and line, and then add a legend, right? And you can basically place your legend anywhere in the plot. So this basically is giving me the trend, what I'm looking at, my rolling average. So similarly, you can look at the trend for wind and solar data. So what we are seeing here is when you look at trend, this is one more way of looking at it. You can always create plots in different ways. So 7-day rolling mean has smoothed out all weekly seasonality, which we were seeing here in my graph, where you look at every 7-day, preserving the yearly seasonality. So 7-day will tell that electricity consumption is typically higher in winter and lower in summer. So better is you break it down yearly. So here, if you look at every year, you can see when is winter, when is summer, what is the seasonality, what your trend, what you're seeing here, and if there is a decrease or increase for few weeks every winter. So similarly, if you look at 365, now as I said, rolling average basically reduces the variation. So if I look at 365 rolling mean, we can see long-term trend in electricity consumption is pretty flat. Now that's what we are seeing. It's kind of pretty flat. There is not much variation over years if you really join these dots. So we can basically see some highs and lows, and that gives me a trend. Now this is how you can do a trend detection, and similarly we can do plotting for wind and solar. So this is a small project which I demonstrated using R. Now all this code which you have here in the form of a project.r file you can find here in my GitHub page. This is the document which explains some things. Feel free to download this and you can add details to it. This is the sample data set which you can also find in my repository in the datasets folder. So continue learning and continue practicing